In this model, you will integrate the provided front-end project with your microservices architecture to understand how a real-world, modern single-page application can interact with microservices that have been secured with OAuth 2 and OpenID Connect. By the end of this model, you will have a solid understanding of the following: how to enable coarse support in the identity microservice, how to configure a React-based single-page application client in Identity Server so that it can interact with the other microservices, how to use the ID token obtained from the OpenID provider in a single-page application to dynamically render content based on the token claims, how to use the access token to invoke secure microservices from a single-page application, and how to update the identity microservice to properly support signing out of the application. In terms of our overall system design, this model is all about integrating the updated front-end application with the identity microservice. Please keep in mind that at this point, the front-end will continue talking directly to the microservices, which is not ideal, but we will stick to this approach for now so that you can focus in the identity and authorization aspects of the front-end to microservices communication without the complexity of the introduction of an API gateway. Let's get started. It is time to try out our updated front-end portal with the microservices we created and secured in this course. If you have not done it already, please grab the source code for the front-end as indicated in the previous lesson. And also, remember that you will need Node.js in your box to be able to run the application. As you can see, I have already downloaded and extracted the front-end source code under play.frontend in my projects directory. So let's switch to play.frontend. And now let's open this Visual Studio Code instance in that directory. So I'll do code dot and then -r to reuse this window. And here we are. So this is a revised version of the front-end single-page application used in previous models. So it has several modifications and additions to account for identity and authorization related scenarios. We will explore what has changed later, but for now, let's start by installing all the dependencies. So I'll just do npm install. And this may take a few seconds or a few minutes depending on how much time it takes to download all the dependencies. And with that, we should be ready to start our front end. But before doing that, let's make sure that our identity microservice is also up and running. So I'll switch to play.identity over here, and I'll open a terminal also, and I'll switch to src play.identity service, and I'll just do .NET run. All right. So switching back to front end, I'll do npm start to start the Node.js web server for the front end. This should take just a few seconds. And now we can browse to the front-end portal by using the local address over here, http localhost 3000. So I'm going to control click over there. And here we are. So this is a modified version of the front-end portal that you're familiar with from previous models. However, there's something different here. As you can see, we are missing items from the top navigation bar, like there's no catalog and there's no inventory menu items anymore. And this is because this version of the front-end portal is aware of the identity and the authorization of the logged-in user. Since there's no logged-in user right now, it cannot show any of these items so far. And we are doing something similar also in this homepage, where there will be more items in this list here, next to check your inventory, depending on if the user is logged in and on the role of the user. Additionally, there's a new menu item at the top right here that says login. So this is the option that you can use to actually sign in the user into the system. So let's try that out. Let's click on login and see what happens. And as you can see, we are hitting an error right now. And to get a better idea of what's going on, let's press F12 to open the Chrome Developer Tools. F12. I'll scroll up all the way there, and perhaps I'll do this. What it says is access to XML HTTP requests at this address from origin localhost 3000 has been blocked by course policy. So this is something very similar to what we face when we try to access both the catalog and inventory microservices from the front-end portal. So the only thing that needs to be done here is to do the proper configuration of the course policy for the identity microservice. So let's work on that. I'll go back to the identity microservice codebase, paste the identity over here, and I'll go ahead and stop my web server by doing Ctrl+C in the terminal. And I'll open app.settings.development.json. I'll close this terminal. And so here we're going to add a section for allowed origin. It's going to be HTTP localhost 3000, just like we did with the other microservices. Now I'll go to startup.cs, scroll down a bit, and at the top I'm going to declare a variable for this allowed origin setting. So I'll say private const string load origin setting equals the one that we just created, allowed origin. So I'll copy this there, and I'll collapse this for a moment. And now we have to actually configure the course policy. So I'm scrolling down all the way to the configure method. Inside the m.isDevelopment section, I'm going to add a few more lines here, just like we did with the other microservices. So app.useCourse, then we say builder. Okay, we open this section here. So we will say builder.withOrigins, and then we'll use a configuration object to read that key that we just added to app.settings.development.json, which is allowed origin setting. And then we have to specify that we want to allow any header, and we want to allow any method too. And that should do it. So what I'll do now is I'll bring up the terminal again via Ctrl+J, and I'll do .NET run once again. Okay, so now back to the portal over here. I'll close this console, and I'll just go back to our front end in localhost 3000, refresh. Here we are. And now I'll click on login once again. And I think there's something still going on here because login is just taking way too much time. And in fact, we are getting redirected to some error page. So something is still off here. And this is not about course. Now let's take a look at the console of our identity microservice actually over here, and let's see what we got. So if I expand this a bit, we can see that there's some failure here. So it says that unknown client or client not enabled, unauthorized client. And this makes sense because we have not yet configured the front end client here for proper authorization in our identity microservice. Remember that we had to do this with the Postman client when we initially started using it, and only authorized clients can get access to our microservices. So in the next lesson, we will add the proper configuration to authorize our front-end client to access our microservices REST APIs. Just like we did before with our Postman client, we need to add the proper identity server configuration to define and authorize our front end as a client that can access the REST APIs of our microservices. So let's start by understanding what kind of configuration our front-end portal is being using right now in terms of authorization. So I'll go into the SRC folder and then into components. And then here you will notice one new folder that we didn't have before, which is the API-authorization folder. So this folder contains all the authorization related components, our functions, that will be used from here on. In particular, let's take a look at authorizedservice.js. And I'm going to collapse the terminal now. I'm also going to collapse this for a moment. Now, authorized service is our interface to communicate from the front end into any of the authorization related endpoints. And it is actually using an external model for this, which is called OIDC client or OpenID Connect client. So this is a model that we didn't write, that we're just reusing to take advantage of this class called user manager, so that we can perform a series of OpenID Connect related functions on the client without having to worry too much about the actual implementation of those functions. Now, if we scroll down for a bit, we're going to find this function called ensure user manager initialized. And here is where we are configuring the OpenID Connect settings that we're going to be using to talk to our microservices. So here's where you can see the authority being used, which is actually being read from Windows Identity Service URL, which, if you're curious, you can find, let me show you, let me open up my Explorer again. You can find that in public config.js. That's right here. Windows Identity Service URL is defined as localhost 5003, which is our identity server microservice. So back to authorized service. We also have the client ID defined here, which is front end, the redirect URI that we're going to use, which also comes from a variable here, which is a combination of host and port, our local host and port, and the login callback, which again is defined over here in API authorization constants. So that's a location where we are saying that we need to get redirected after the authorization flow has completed. Then we also have response type code, which means that we want to use the authorization code flow. And then we can see all the scopes that we're going to be requesting, similar to the scopes that we've been using so far in Postman. Now, notice that there's also one new scope here, which is called roles, right there at the end. And this is a scope that we are going to need to be able to get the roles claims into the ID token, so that the front-end client can know which is the role of the logged-in user, and based on that, it can show or hide some elements of the UI. And we'll see how to configure this roles scope in a moment. There's also now a post-logout redirect URI, which is used to define where should the client be redirected after logout. But we will configure that later. For now, we have enough information here to be able to configure the front end as a client in Identity Server. So let's go back to the Identity microservice right here. So I'm going to stop this server and close the terminal. And we want to go to app settings.development.json. Over here, let's collapse this. As you remember, here's where we configured Postman, right? So this is the entire section for Postman. And what I'll do is I'll actually copy this entire section to use it as a base for our front-end configuration. And I'll put it at the top, actually. So to start with, let's make sure we use the correct client ID. So going back to front end, here's the client ID that we will be using. It's called just front end. So I'll copy that over here, right there, client ID. Then for allowed grant types, going back to front end, since we're using the response type is going to be code, we want to stick to the authorization code flow, just like it is right now and just like we did in Postman. We will keep using required client secret as false, because that we know that we're using authorization code with PXE protection, which includes the code challenge that will make sure that the proper flow is enforced. Now for redirect URIs, going back again to the front end, we have to use the plain version of this string that's been built over here. So that string would be, let me type it right here, HTTP localhost 3000 authentication login callback. Okay, remember, this is the location where we are expecting to get redirected after the authorization code flow has been completed. For allowed scopes, this is mostly fine, although I don't think we need to specify both full access, read access, and write access for catalog. So we will just stick to full access. I'll remove these two. And then I'll add the new role that I mentioned, which is called, the new scope that I mentioned, sorry, which is called roles. And I'll keep this always include user claims in ID token, because we're going to need that so that roles can be populated into the ID token later. Now, if you want to, you can also start allowing the roles scope in your Postman client down here. And this is kind of optional. You don't really need to do this right now for the front end, but I think it can hurt. So I'll just copy roles and all the way down into the Postman section and I'll add it right there. Now, like I said, we need to specify these roles as a new supported scope in Identity Server. So it's not enough with just declaring that we want to use it in these clients. We have to specify that scope. So for that, I'm going to open up my Explorer again. And we're going to go into Settings, Identity Server Settings, scroll down. And remember that here's where we have defined a few things, and among them, we have included both OpenID and Profile as the identity resources that we want to include. Here's where we're going to include this new scope. So I'll just add new identity resource. It is going to be named roles. As we said, that's the name of the scope. And then we have to also specify which claims are going to be included in this scope. So I'll just declare a new array. And I'm going to include the role claim over here. By doing this, Identity Server will know that anytime we request an identity token, it should include the role that the user belongs to, the logged in user belongs to, as part of that token. And the only thing that you have to do is include the roles scope. And with that done, we should be able to get started with this. So I'll open my terminal again, Ctrl J, and I'll do .NET run once again. Okay, so I'll head back to the front end. I'll just make sure it keeps running. So I'll open up my terminal. So yeah, looks like it's still running. So I'll go back to the front end over here. And it's time to go back to the front end portal. And just keep in mind that here we are not in the front end portal. So this address, localhost 5003, is the identity microservice. So where we want to go is actually localhost 3000. So I'll go there. Here we are. And now I'll click on login. Let's see what happens. So yeah, so now we're getting properly redirected to the login page. And if you remember, this is the same login page that we were seeing as we were generating access tokens in Postman. It's just that now we're getting redirected there from the front-end portal. So now that we're here, we can actually log in. So I'll go ahead and log in as administrator. And I'll click on login. And this is working properly now. You can see that we now have a hello message here for admin@play.com, a logout message on the right side, and also we have a bunch of new menu items at the top over there, including also some new content in the main page. So this is looking good. However, there's still one issue here that we should fix before we move on into exploring the different elements of this new and updated front-end portal. And it's the fact that there's an issue going on with the logout experience. So if we click on logout over here, I click on logout, you can see that we don't just get logged out. We are being prompted to click here to complete the logout, which is not really ideal. We should be able to just go back to the front end already. And the fact is that if I actually click on here to log out, it will log out. However, we stay in the identity microservice. Look at the address. It's still localhost 5003. So now I don't have really an easy way to go back to the front-end portal, right? If I click over here, for instance, I will just get redirected to this location, which is not ideal. So this is a pretty bad experience. In the next lesson, we will fix this logout experience to ensure that users return to the front-end portal after successfully signing out. As we saw in the previous lesson, the sign-out experience is broken, and this is because of a few changes that we're missing in our identity microservice. So let's fix this. To start with, remember going back to our front-end code base in authorized service, ensure user manager initialized. We have a new setting here called post logout redirect URI. So like I said, this is the location where we should be redirected after the logout flow has completed. We have not configured this yet in Identity Server, so we have to do that now. Let's go back to Identity over here, and I'll do Ctrl+C to stop my server, and I'll close my terminal. I'll close Identity Server settings, and I'll go back up into app settings.development.json. I'll go up over here into our front-end client, and here I'm going to include a new section called post logout redirect URIs, and this is an array, so you could have more than one of these. Here we want to introduce that location. So it's going to again start with HTTP localhost 3000. It's going to be inside authentication, and it's going to be named logout callback. Okay, so with that we know where we should be redirected when logout has completed. However, that's not enough. We also need to introduce a few changes into the logout page, the logout razor page, to indicate that if the logout process has completed successfully, we should just go ahead and redirect directly into the home page of the portal. However, so far, if you look at the pages section, let's see, if we look at areas, account, over here, we only have the register page so far. We don't have the logout page, and that's because we did not generate that when we initially generated the register page. But that's very easy to fix. So I'll open up my terminal again, Ctrl J. And what I'll have to do, just temporarily for now, is to add a couple of NuGet packages once again so that we can do code generation. So I'll do .NET add package, Microsoft, that entity framework, core.design. Perhaps I'll collapse this a bit. So I'll hit enter. And then we will also add Microsoft.entity framework core.SQL server. Enter. So it's a bit sad that we have to do this, but it's really the only way to make sure that we have all the prerequisites for the code generator to work. So now that we have those, we can go ahead and do, and I'll also close this for now. I'll do .NET ASP.NET code generator identity, and then I'll say files. We want account.logout. Hit enter. And so now the code generator is going to go ahead and extract the logout screen, the razor page, from the built-in files that it provides for ASP.NET Core identity. So with that done, let's move this. If we go to areas, pages, account, now we have the pages for logout, as you can see over here. But we also have a few other things that we don't need. So I'm going to delete this data directory that we don't need. So just delete that. I'll also delete identity host and startup.cs that we don't need. I'll also go into play.identity service.cs proc. I'll collapse the terminal now, because now we have this entity framework references that we don't need. So I'll remove those. Entity framework.design and entity framework.SQL server removed. And lastly, in updating.json, we got an undesired connection string right here that we of course don't need because we are not using SQL server. Okay, let's close this and that. And now let's focus in that logout page. Let's go to logout.cshtml.cs. Collapse this. So like I said, this is the page that contains the logic that executes when the user logs out. So we want to modify this to tell it that we need to go back to the front-end homepage once logout has completed. And to do that, what we're going to do is take advantage of a built-in class from identity server that we can inject here, and we can use to ask for information that can tell us if we're ready to go back to that front-end homepage. So let's add one new variable over here just after the logger. We're going to say private read-only identity server interaction service, and we will call it just interaction. Okay, I'll do a control dot here. Let's do using identity server for that services. And of course, this will have to inject into the constructor. So let me put this down there, and then I'll add this one here. And then I'll just do this, that interaction equals interaction. Okay, so now the core logic that we want to write will happen actually on the onGet method. This is the one that executes when we arrive to the login, to the logout page, sorry. Now on this onGet method, we're going to need one variable here being passed in so that we can tell which is the logout context of the user that's currently logged into the system. So this is kind of an internal detail, so this is going to be passed in by identity server for us, as long as the client is configured properly. And the name of the variable that we're going to use here is just going to be called logout ID. So with that logout ID, what we can do now is say var context equals await interaction dot get logout context async with logout ID. Of course, now that we're using await, we should turn this into async task of I action result. Okay, so with that, we now have contextual information of the current logout flow. And if things have been configured properly, we can now ask if context, and I'll use question mark here, just in case that context is null. We shouldn't, but just in case. Then I'll say show sign out prompt equals false. This flag here you can use to tell if the user should be prompt for sign out or not, and that is being provided by identity server. So we don't really have to worry about how this prompt is being populated. If everything has been configured as we have done in this course, at this point it should return false, and if it does, it means that we are safe to go ahead and sign out and redirect to the home page. So what I'll do here is I'll just say return await this done post, and then I'll do context that post logout redirect URI. Okay, hit save. Remember that this is the URI that we just configured in upsetting developing.json, and that's a location where we're expecting to get the user redirected after logout. Then on post is just this method that we have down here, which is the one that's going to cause the redirection to happen. But before going there, one more thing that we have to do is just to finish this method and say that if a show sign out prompt is not false, which is true, then we're going to just present the page. So return page. So that will be the behavior that we have had so far. And the user has to confirm the logout. One last thing that we want to change here is in on post, it shouldn't be a local redirect, because remember that this is the identity microservice. We don't want to be redirected to identity microservice. We want to be redirected to our frontend, which is in a different location. So local redirect is not going to work. We want to do just a simple redirect, just like this. Now there's one more thing that we have to change here. And if you scroll up all the way here, you're going to see that we're using this identity user object for sign-in manager. But that's not quite what we need to use. That's kind of the default user that you would use for ASP.NET Core identity. But as you might remember, what we've been using here is another one called application user, which if you open the Explorer, you remember that's the one that we have declared as our entity right here. Application user. So this application user is the one that we need to use in any instance of the sign-in manager or of any of these other managers we've been using. So I'll close that and I'll use that over here. And I'll import control.play identity service entities, and also over here, identity user, application user. And with that done, we should be able to try out the updated logout experience. So what I'll do is I'll just place a breakpoint down here in the onGet method, first line over there, just so that we can see how things move forward as we do this new logout experience. So then I'll just do F5 to start debugging. So F5. Okay, so debugging just started. And I'll also collapse this on the left side. And so now let's go back to the frontend portal. And I am right here, not logged in yet. So I'll first log in. I'll enter again as administrator. Log in. And now we can try out the logout experience. So I'll go ahead and click on logout. And our breakpoint has fired. And as you can see, if we go over logout ID, we are getting this logout ID provided by the identity server infrastructure. So this is good. And then if we step over this line, we'll see that we are able to get a context based on that logout ID. So that's a way that we can identify which is the actual session of this user in the system, and the logout context that we can use to verify if we are good to just redirect the user directly into the home page without prompting. So we can use, as you can see, the show sign out prompt variable here, which is false. It is telling us that, yeah, you're good to go directly into just signing out and going to the home page. So I'll just step over that. And again, and this will take us to the onPost method down here with the post logout redirect URL that we have configured before, as you can see. And then if I just hit continue and we go back to the front-end portal, you can see that logout has completed. We are successfully logged out. And more importantly, we are now in the domain of the front-end portal. As you can see, localhost 3000. We are no longer in the identity microservice. So if you just click on play that economy, we are back into the home page. So this is the kind of logout experience that we would expect from the system. In the next lesson, we will explore how the updated front-end portal is taking advantage of OpenID Connect ID tokens to secure and dynamically render UI elements based on the claims of the sign-in user. Let's now explore in more detail how the updated front-end portal is taking advantage of OpenID Connect ID tokens to secure and dynamically render UI elements based on the claims of the sign-in user. So here I'm back in our front-end portal, and I'm not signed in currently. So as you can see, we are missing a few elements from the navigation bar, right? So I don't have inventory, catalog, or anything else right here. And so as I log in, so I'm going to go in as an administrator. You can see that now the elements show up, my inventory, catalog, and users, as well as hello admin, the logout menu over there. And also I have new elements on the index page right here. So how is all of this working? Let's go back to the code of the front end. And so let's now go into our components directory and into navmenu.js. I'm going to collapse terminal for now, and this a little bit. And then if we scroll down, you're going to see that here is the render function where we render all these navigation elements. And now what we have is a function called check auth and render menu items. If we go into that function down here, you're going to see that now we're relying in a Boolean value is authenticated to decide if you're going to show an anonymous view or an authenticated view, where the anonymous view, which is down here, is going to show only the home and the login links, while the authenticated view is going to show, depending on the role of the user, is going to show, well, home, inventory, my inventory, catalog, users, plus the profile and logout items, which are actually down here, like hello, username, and logout, right? And so it's going to show either that, or if the user role is a player, it's going to show only home, my inventory, and then again the profile and logout items. So we're taking advantage both of the authentication state of the user and the role that the user belongs to. And it's going to be actually similar to what we do in our home.js page. If you go to home.js, which is the one that renders the home page, you're going to see that in the render function, we now have an admin view in this section that is the one that controls that if we are authenticated and if the role is an admin, we're going to show the links to catalog and to users. So let's go back to nav menu and see how is this really working, right? So where is this state role admin coming from? And where is authenticated being populated in this state? So if you go back actually up here into populate state, this is the function that will actually invoke the auth service is authenticated function to determine if the user is authenticated. That's a Boolean value that we get on the left side. And also it invokes the getUser method to retrieve a user object, that's right here, and from which we extract the name and the role. But how are these functions actually working? If you go into is authenticated, then I'm going to do F12 here. So now we are back into API authorization and into the authorized service.js file. Okay, and I'm going to collapse this for a moment. Here, if you notice, we do have an is authenticated function right here. That what it does is it invokes the getUser function to retrieve that user object. So what is getUser doing? So notice that getUser is just taking advantage of the user object that was populated just after we signed in the user. That user object has many properties that are actually derived from the ID token that we obtained from Identity Server or our Identity microservice. And to get a better picture of how that ID token is being used to populate the user and profile objects over here, what we're going to do is a debug session. So first I'll go ahead and open my terminal and I'm going to stop my web server, Control-C, stop web server, and then I'll go back to my browser. I'll just close it for now. And then I'll close this terminal and then I'll switch to the run and debug view over here. And I'll start with the server/client option here. I'll start with that. So that opens up the browser once again, and it's going to start the web server in debug mode. If we go back to VS Code and we open terminal again, Ctrl-J in debug, in the server side, we'll see that the web server is starting. In debug mode, things always take a little bit more to start. So just give it a few seconds. Okay, so the server has compiled and it has started. If you go back to the browser, we're on the home page again. And now what I'll do is I'll log in once again as an admin. Log in, say never. And now I'll go back to VS Code and I'll place a breakpoint in this getUser function. I'll scroll down this. GetUser right here to see what we got in these variables. So back to the browser, I'll just refresh. And back to VS Code, now we can see what's going on behind the scenes. So if we expand this user object, we're going to see that we have a bunch of details here, including the access token and the ID token right there. So if we explore the ID token, I'm going to copy the value of this ID token. And now I'm going to browse to jwt.ms. And I'm going to paste that token over here. There. You're going to see that now we have our admin role being populated right there as a claim, and the username or the email is present in the preferred username and in the name claims over here. And of course, the audience is the front end in this case. So this is the information that's been used to populate that user object that you have over there. And we also have this more explicit profile object that includes all this information, including so the name, preferred username, the role, and also the sub identifier, which is pretty important, which, as you remember, identifies what is the unique ID of the current user. Okay, so I'll just remove this breakpoint and then I'll collapse this a bit and I'll hit play. And then that's how the items are being rendered here dynamically. And of course, according to the logic that we saw, if we switch the user, the elements should also switch here. So let's try that out. So I'll just log out and then I'll go to home and then I'll go to login once again. And I'll say player1, play.com, password, and then login. And as you can see, this time we only see my inventory navigation option, and we only see the check your inventory option over here. And then one more thing to understand is that the different client-side paths that are enabled in this front end are also protected via the ID token or by the information that we obtain from the ID token. So for instance, if I just log out now and then I go to home and I try to go to this check your inventory option, which as you can see down there is going to take us to localhost 3000/inventory. Let's see what happens. So I click on inventory and I'm immediately redirected to login. If I go back and I try to do something similar but with /users, which is our users route in the client side, hit enter, same thing happens. So you got redirected to login. So why is this happening? Well, if we go back to, again, to the front end code base, and this time let's go to Explorer, let's go down into app.js, let's collapse this and close that. So if you go down, you're going to see that as we lay out a different client-side routes of the portal, we're now no longer just using the route component, but we are actually using this new authorized route component here for the elements that need authorization. So this element ensures that you have to be signed in into the front end before you can arrive to any of these locations that are secured. And so if you go to the to authorized route, I'll do F12 to go to the definition of this authorized route over here. You're going to see that when we render, we are actually checking the authentication status of the current user to decide if we are going to just render the element that was requested, or we're going to get redirected to the login URL. And of course, this authenticated element comes from the state that has been populated over here in populate authentication state, which again goes back to auth service to retrieve the is authenticated value. Okay, so I hope that gives you a good idea of how the OpenID Connect ID tokens are really powerful in how they can be used in the client side to render different elements and protect these different elements in the UI. Now, in the next lesson, we will explore how the frontend portal is taking advantage also of OAuth2 access tokens to make authorized calls to the microservices that we secured in the previous models. Let's see now how the frontend portal is taking advantage of OAuth2 access tokens to make authorized calls to the microservices that we secured in the previous models. So here I am back in the frontend portal, and I am actually in a debug session of the frontend portal. And I'll start by logging in once again as administrator. So admin. And what I'd like to do is to go into the catalog section to see how we are populating the access token needed to be able to invoke the catalog microservice. So first what I'll do is I'll go back to the front-end code base, and the action is actually happening, if you go back to Explorer, is happening in catalog.js under source components, catalog.js. I'll open up that, minimize this for a bit. And as you scroll down into the populate items method, you're going to see that now we're not just talking directly to the catalog items API. I mean, we're talking to it, but before doing that, we're actually invoking the get access token method of auth service, which in turn, if we go into that function, what it's going to do is to, again, retrieve the get user, get user from the get user function of user manager, and from that user, it acquires the access token. So going back to catalog.js, that's how we retrieve that token. And once we have it, we're able to go ahead and use it as a header, as the authorization header for the invocation to the catalog microservice. And that's what's going to allow the authorized call over there. So I'll actually place a breakpoint over here so we can take a look at that access token. And then before we execute this, let's actually make sure that we have our microservices up and running. So I'll go back to the catalog microservice code base over here. I'll open up my terminal. Let's see. I'll go to terminal and I'll go into src, play catalog service, and I'll do .NET run. And I'll do the same thing for the inventory microservice that I have over here. Open terminal. And I'll do src, play that inventory service, .NET run. Okay, microservices are running. We have the breakpoint ready. So here we go, back into the frontend portal. I'll click on catalog. And as you can see, here we are in the catalog.js file. And now let's take a look at what's in here. So we have acquired an access token right there from the auth service. And if expand this, I'm going to go ahead and right click and copy this value from the left side and into our familiar jwt.ms page. So I'll just delete that and I'll paste this. And as you can see, this is nothing more than a familiar access token like the ones that we've been using so far in this course, which has the important information like who is the issuer, which are the audiences, which is the client ID that's logged in right now, which is the sub of the current user, the role of the user, and the different scopes that have been requested. So it's just another access token like the ones that we've been using in Postman so far. Okay. So that's going to be used right here as a better header. And if you just remove this breakpoint and we let it continue, we'll see that the catalog items are properly populated. The same thing is happening with the new users section that we have over here. So if you click there, this is invoking the users REST API that we enabled in the identity microservice. And that's all happening back into play.front end. If we go back to Explorer, that's happening in this new file that's over here, users.js, which is doing something very similar. In populate users, it just retrieves the access token and then it invokes the users REST API. That's in the users API URL variable. And then of course, just next to this users.js, we also have, actually inside the form directory, we now have user form and user model, which are in charge of being able to change the details of a user. So if you go back to the front-end portal, let's say that now we want to increase the amount of yield of, let's say, player 1. So now what we can do is click on edit. And here we can grant those 200 yield to this player. Hit save. And that makes an authenticated and authorized post call into the user's API. If you go back to Visual Studio Code, that's going to happen in user form. In the update user method, this time is not a get call, but it's a put call. But again, we just get the access token. We put it in the header, in the authorization header right here. And then we just send the post call down into the identity microservice. Now let's see how we can actually grant an item to this user now. So I'll go back to the front-end portal. And what I'm going to do is to copy the ID of the player 1. So I'll copy this ID and then I'll go back to catalog. And let's say I'm going to grant some antidotes to this user. So I'm going to click on grant. And this time in this version of the front-end portal, the user ID is no longer auto-populated because we want to use real user IDs, not just randomly generated ones, because we now have a user's database. So I'm going to paste what I just copied right here, paste it. And let's say we want to grant 3 antidotes to this user. And so I'll click on grant, and that should have granted 3 antidotes to the user. So if you go back to users and we click on this inventory bag that we have right there next to the player 1, you're going to see that now it shows the 3 antidotes that this user has alongside the 3 potions that it had already. And not only that, we can actually make it so that when player 1 logs in, he can see his own inventory and only his own inventory as per the rules that we defined in the previous lessons. So if we go back to home and then I'll log out, then I'll go ahead and log in as player 1. Log in. And before we go into my inventory, let's actually go back to Visual Studio Code. And let's go into inventory.js. Scroll down into populate items. And here we have a little bit of conditional logic. So the items are going to be rendered depending on where you came from. So in this function, in populate items, we have this came from users page function, which I'm going to dive into, which checks the fact that if we have something populated into the location object over here. So if we do, it means that we came from the users page, Otherwise, we didn't, which is the case that we're going to evaluate right now. So in that other case, we're going to be able to retrieve the user object from the auth service and then extract the subclaim from there. So I'm going to place a breakpoint here. And I'll also place a breakpoint in the inventory microservice to see how we land on that side. So here we are back in inventory microservice. I'll do Control-C to stop the web server. And I'll actually go into controllers, items controller, into our getAsync method. Okay, and I'll place a breakpoint over here. And now I'll start debugging this microservice. So I'll click on Run and Debug, and I'll click on Play over here. So that starts the debug session for inventory. And so now back to the browser, I'll go into my inventory. And here we are in Visual Studio Code in the front end. And I'll step into the came from users page function, step into that. And we'll see that the user location is not available right now because we're not in the users page. So I'll just step over, and now we are down into the else branch here, where we want to retrieve the user object. And from that user object, we have acquired the sub claim, which is what we're going to need down there. So if you just keep going down, get the access token, and then we're going to need that user ID to be able to invoke the inventory items API URL. You remember, we can pass the user ID to specify which is the user for which we want to obtain the inventory items. And with that, I'll just hit continue. And now we have switched to the play.inventory Visual Studio Code instance in the getAsync method, where we have received the user ID that we passed. As you can see, it's right there. It's not that easy to see over there. User ID. Let me collapse this and that. Okay, it's right there, the user ID. And then also down here, we're going to extract the subclaim from the authenticated user that came from the access token. So if you just step over that, we're going to see that we also acquired that user ID from there. So we're getting it both from the user ID that we read in the client side from the ID token, this user ID, and also from the access token that we passed into this method as we invoked the method. So of course they should match. So let's step over, and then we're going to be able to retrieve those inventory items. So I'm going to just remove this breakpoint now, hit continue, and then back in the browser, you can see that we are able to see which is the current inventory of player one. Okay, so hopefully that gives you a good idea of how access tokens can be used from the client and the real world client to talk to secured microservices. Now there's just one more thing that we need to fix here, and it's the fact that if I go to logout, so I have logged out, I'm in home now, and then I click on login, and then I click on register over here in the top. There's actually an issue here, because if I register a new user, so let's say I register player 3 at play.com, and I hit register, this happens. So we are not getting redirected to the homepage of our frontend portal, but instead we came back to the root of our identity microservice, and this is not what we want to happen. So there's something missing here. So in the next lesson, we will make a small modification to our identity microservice to fix this new user registration experience. Let's see now why the user registration experience is broken and what we can do to fix it. So as you remember, if we go to the login page over here, and then we click on register, things are going to fail. But one thing to notice is that we don't have the return URL anymore in the address bar. So if you just go back one page, notice that we did have a return URL over here. So that's what would have allowed us to return there after the login completes. But once we go to register, that return URL is gone. So that is the key piece to fix in order to fix this whole register new user scenario. So how do we fix this? It's actually pretty straightforward. If we go back to our identity microservice code base right here, and I'm going to stop my web server for a moment. Let's go into pages, shared, and into the login partial Razor page. I'm going to close terminal, and I'm going to collapse this. If we go down here, we're going to see that here's a section where we are rendering both the links to register over here and to login in the top right. And so the only thing that we have to do is to add the proper attribute to preserve that return URL as the user clicks on those links. And we can do that very easily by adding, and perhaps I'll just make some space here. It's too long, so I'll just put it down there. So like this. So here we can add an attribute called ASP route return URL, and on that one we're going to assign model.return URL. And really that's all we have to do. I'm going to copy this from register. Also, let's also fix login because it will also be broken here. So I'm going to take this down a bit, and then right there, that's going to fix login. So anytime we render either the register or the login anchors or links, the return URL that we received from the previous page is going to be included. All right, so I'll go back and restart in my terminal. Back in the terminal, I'll do .NET run. Okay, and then back in the browser over here, I'll go back actually to the home page. So let's go back to localhost HTTP localhost 3000. This is our root, and then I'll click on login, and then I'll click on register. Notice that now the return URL is right there, both for register, and if I click on login, it should also be there. Back into register, this time I'm going to register a brand new user. Let's say I register player4, play.com. Okay, click on register. And now we are in the home page, which is the nice and expected experience. So that marks the end of this module. You have integrated an identity-aware React-based single-page application with the identity microservice to enable a bunch of new identity and authentication-related scenarios, which are only possible thanks to OpenID Connect, Identity Server, and ASP.NET Core. I hope you have enjoyed building this system with me so far. In this module, you will learn about transactions in a microservices architecture and how you can use the Saga pattern to implement a business process that involves multiple microservices. By the end of this module, you will have a solid understanding of the following. What are database transactions and how they traditionally work in a monolith? What is a distributed transaction? What is and how does the two-phase commit algorithm work? What is a Saga and how does it work in the context of a microservices architecture? And what is the difference between a choreography-based Saga and an orchestration-based Saga? Let's get started. In this lesson, you will learn about the need for transactions in your applications and how they work in the context of a monolithic system. To understand why you may need to use transactions in your applications, let's go back to our fictional game client where the player wants to purchase some items from the game store. The player requests the purchase of some quantity of a specific item, and then the application proceeds to grant such items to the player's inventory bag, but also it debits the corresponding amount of yield from the user's wallet. What you have to think about here is what happens if the app fails to grant the items to the player, even when it successfully debited the yield from the wallet. The player would certainly not be happy about spending yield to get nothing in return. But also, what if it is the other way around, and the problem is that the game was not able to debit yield from the player? Because perhaps the player did not have enough yield to spend on that number of items. And even so, the items were granted to his inventory. That would result in a very happy player. But now our game economy is suffering an undesired inconsistency. Here is where transactions come to the rescue. In a transaction, a set of operations are treated as a single unit, in such a way that either all the operations complete successfully or all of them are rolled back together. Therefore, with a transaction, we can ensure that our game both grants items to the player and debits yield from him, or both of these operations are undone as if none of them ever happened. Let's see how transactions work in a monolith system. Here, our monolith includes only one service, the trading service, which is responsible for performing the purchase operation by updating both the inventory and users tables in its associated relational database, or inventory and users collections in a NoSQL database like MongoDB. Let's say the player requests the purchase of 5 potions, which the client app translates into a purchase request to the trading service. The service then adds 5 potions to the inventory table row for this player, and then it reduces the amount of yield of the player by, say, 25 in the users table, assuming each potion costs 5 yield. But to make sure these both happen in a single operation, the service performs both actions in the context of a database transaction. This means the database will not consider any of the operations as completed until the service sends a commit command to the database. Only after this, any future query operations against any of the tables will find the updated values. This type of transaction is usually known as an ACID transaction. ACID stands for atomicity, since all operations must complete or all of them should fail. Consistency, because the database must be left in a valid, consistent state. Isolation, meaning that all operations can execute at the same time without interfering with each other. And durability, because when the transaction completes, the data won't get lost even if there are unexpected system failures. Now, as you move to a microservices architecture, the main issue you're going to hit is trying to get atomicity across your operations, because each service now has its own database and, generally speaking, ACID transactions are meant to happen within a single database. This is where you usually start thinking about distributed transactions, which is a topic of our next lesson. In this lesson, you will learn about distributed transactions and the challenges presented when implemented via the two-phase commit algorithm. What is a distributed transaction? The following definition, taken from Wikipedia, describes it pretty well. A distributed transaction is a database transaction in which 2 or more network hosts are involved. This usually means that instead of performing the transaction in a single database hosted in a single server, you need to perform the transaction across multiple databases hosted in different computers or nodes on a network. As you can expect, this is pretty challenging, but there is a common algorithm typically used to ensure the correct completion of distributed transactions, which is known as two-phase commit. To understand how the two-phase commit algorithm works, let's go back to our purchase scenario, now in the context of our microservices architecture. Here we have again our client and our inventory and identity microservices, each of them with their own database. The two-phase commit algorithm requires a central coordinator, which drives the whole distributed transaction. So let's bring in a new trading microservice to fulfill this role. Once again, our user requests the purchase of 5 potions via our client app, who sends the corresponding request to the trading service. Now, instead of sending a request to inventory to just grant the 5 potions to the user, it asks a question. Can you grant 5 potions to this user? This is what we call the voting phase, and to honor this request, inventory will likely need to lock the corresponding database record to make sure no other process can modify it until the distributed transaction is complete. Inventory would then confirm it can grant the 5 potions to the user. After that, trading asks a similar question to the identity service. Can you debit 25 yield from this user? Identity would likely confirm the user has enough yield available, and then would also log the user database record to make sure no other process can modify the amount of yield. Identity also confirms it can perform the requested operation. At this point, if any of the participants state that it cannot fulfill the request, the entire transaction is aborted, and no change is applied. However, if the coordinator has received a successful confirmation from all participants, then it moves to the commit phase, where it requests each participant to complete the requested operation. Inventory will then actually make the update in the inventory items table of its database, releases the log, and reports the success back. And the same way, Identity updates the user's table, releases the log, and reports the success. Finally, the coordinator reports the successful completion of the transaction back to the client. This solves the issue of making sure all changes happen across all participants or none of them happen. However, it does present a few issues too. To start with, the fact that the coordinator has to wait for each participant to reply with a yes or no during the voting phase can inject huge amounts of latency into the system. Keep in mind that not only trading, but also inventory and identity are all waiting at that point just to move to the next phase. And in the meanwhile, there could be dozens or hundreds of other purchases waiting to get fulfilled. The locking of resources in each service can also become a serious performance bottleneck. None of the participants can allow modifications during the voting phase, so we could again have lots of processes waiting for those logs to get released, slowing down the overall system. Finally, there are a bunch of error scenarios that could complicate things further. For instance, think about what would happen if one of the services becomes unavailable during the commit phase. We have been designing our microservices to make sure the availability of any of them is never an issue for the others, but now an outage in a single service can put everything into a very problematic state. So in general, the best advice I can give you is to avoid distributed transactions when building microservices. It's just not worth it, and there's a much better approach to tackle transactions across microservices. In the next lesson, we will learn about sagas and how they can coordinate things without the issues presented by two-phase commits. In this lesson, you will learn about sagas, what are they, and how they work in the context of a microservices architecture. So, what is a saga? A saga is a long-lived transaction that can be written as a sequence of transactions that all complete successfully, or the compensating transactions are executed to amend a partial execution. This concept was introduced in a paper published in 1987 by Héctor García Molina and Kenneth Salem. In essence, a saga helps us to think about our multi-microservice business process as if it is really only one transaction composed of a series of independent sub-transactions and corresponding compensating transactions. In a saga, all these sub-transactions must complete successfully, or if there are failures, the compensating transactions are executed to roll back everything. Let's see how this works. Let's bring back our inventory and identity microservices. Here, our long-lived operation is our purchase process. The process starts by asking inventory to grant 5 potions to some user. Inventory goes ahead, runs a local transaction in its database, and comes back with a successful response. Then, the process makes a call to identity asking it to debit 25 yield from the same user. And in a similar way, identity makes a database update in its own local transaction, after which it replies with a successful response. If all the participants completed their part with no issues, we consider the overall purchase process as completed successfully. Notice that even if we cannot consider the overall purchase process as an ACID transaction anymore, the individual changes to each database can keep using ACID transactions. Now, to provide some form of atomicity to the purchase operation, we make use of compensating transactions. So, for instance, Let's say identity is not able to debit 25 yield from the user, because the user just doesn't have enough yield. This triggers a series of additional transactions to compensate what was done before. In this simple scenario, there's only one compensating transaction, where we ask inventory to take back the 5 potions it granted to the user before. After the compensating transactions are completed, we consider the overall purchase transaction as rollback. The main benefit of a saga, as compared with the two-phase commit algorithm, is that there is no database locking anymore. Instead of waiting for all other participants, each microservice performs the requested operation and moves on. Also, if asynchronous messaging is used to communicate with the saga participants, the fact that any of them is temporarily unavailable won't impact the success of the overall process, because of the asynchronous communication benefits we discussed in previous modules. Now, there are two ways things can get coordinated within a saga: choreography and orchestration. Let's explore these two types of sagas in the next lesson. In this lesson, you will learn about the different ways sagas can be implemented or coordinated in the context of a microservices architecture. When using choreography, the decision-making of each step of the saga is performed by the saga participants themselves. No central coordinator is involved. Here we have our inventory and identity microservices, and also a trading microservice, whose job is only to receive the initial request for a purchase from the client. The client places a purchase request for 5 potions. Trading then emits an event stating that a purchase has been requested. Remember that events are a type of message that are published so that any other services can subscribe to them and act accordingly. They are not sent directly to any service. In this case, inventory has subscribed to the event, and it proceeds to grant 5 potions to the user in its local database. It then fires an items granted event, to which identity is subscribed. Identity will go ahead and debit 25 yield from the user, and then it publishes a yield debited event. Trading has subscribed to this event, and when it arrives, it knows that all operations must have completed successfully. So it replies to the client with a successful response. But what if identity is not able to debit the 25 yield from the user? In that case, a yield debit failed event is raised by identity, which inventory is subscribed to. Inventory then executes its compensating transaction, where it will take back the 5 potions originally granted to the user. Trading was also listening for yield debit failed events, and if it arrives, it knows that something went wrong, and it replies with failure to the client. A key benefit of a choreography-based saga is how loosely coupled the participants are. Notice that neither inventory or identity have any knowledge of the other participants or about the fact that they are part of a bigger transaction. They just listen to an event, perform their operation, and fire another event. Since all the logic lives in each microservice, there is also zero risk of getting any logic centralized anywhere. But there are also drawbacks. As you can tell from this diagram, it can be hard to build up a mental model of the whole process. In our example, we only have a few participants. But what if we involved 5, 10, or more? Could you be able to tell what's going on by just looking at the diagram? Also, it's unclear what is the current state of the saga. Have the items been granted? Has a yield been debited? Has something failed along the way? You would need to either ask each individual service or build some other view out of the published events to tell the current state. Let's now see how this compares with an orchestration-based saga. In an orchestration-based saga, the coordination logic is centralized in an orchestrator service, which sends commands to each participant to tell them what to do. In our example, the trading microservice is now an orchestrator, overseeing the overall transaction. Once again, the client sends a request to purchase 5 potions. Trading keeps track of this request in its local database, and then sends a grant items command to the inventory microservice. Remember that commands are the type of message that are sent directly to a service as opposed to being published for anyone to subscribe to. Inventory will go ahead and perform its local transaction where it grants 5 potions to the user. Then it publishes an items granted event which trading is subscribed to. Trading records the fact that items have been granted in its own DB and then sends a debit yield command to identity. Identity performs its local database update to debit 25 yield from the user and then publishes a yield debited event. Trading records this event in its local DB and then it knows the overall transaction has completed, at which point it can reply to the client with a successful response. Notice that the client does not need to necessarily sit and wait for a response from trading. It could also just send the original request and then start polling trading from time to time to ask if the transaction has completed. Of course, there could be issues during the process. So what happens if the yield cannot be debited in this case? Well, then identity fires a yield debit failed event, which trading is subscribed to. At that point, trading keeps track of this failure and then sends a subtract items command to inventory, to which it responds by executing the compensating transaction that takes away the 5 potions originally granted to the user. And then it replies with a failure to the client if it was waiting for a response. In terms of benefits, as you can see from this diagram, it is easier to understand the whole process, especially because trading is the one sending commands to each service depending on the success or failure of the previous command. It's also easier to tell the current state of the overall process because trading is keeping track of the result of each step. There are also some drawbacks. As you can imagine, we now have higher domain coupling because now our trading microservice needs to know about each of the other participants in order to tell them what to do at each step. Also, there's a risk of centralizing too much in the orchestrator, which could result in a smart orchestrator but dumb microservices. These issues can be mitigated to some extent by making sure that the only responsibility of the orchestrator is to drive the coordination of sequencing logic, but avoiding having any kind of business logic on them. In this course, you will implement an orchestration-based saga, since I believe it's easier to reason about in a beginner-level course like this one, and it should work well in most scenarios. However, feel free to opt for a choreography-based saga if you would like to go for a more decoupled approach and the additional complexity is not a concern for your team. In the next module, we will prepare our existing microservices to participate in the upcoming purchase saga. In this module, you will take the first steps towards the creation of an orchestrated purchase saga by updating your existing microservices to support the required events and commands. By the end of this module, you will have a solid understanding of the following: the flow of the saga that drives the purchase process, how to update the catalog microservice to publish prices when creating or updating items, how to update the inventory microservice to grant items via asynchronous messages, how to update the identity microservice to debit yield via asynchronous messages, and how to ignore exceptions that should not be retried when consuming messages. Let's get started. In this lesson, you will get an overview of the orchestrated saga that you will build to drive the purchase flow. Let's see which are the steps and the participants involved in our upcoming purchase saga. It all starts when the client sends a request to the trading microservice to purchase some items. Since this process involves a long-running operation and we don't want to keep the client waiting, trading only publishes an event with the details of this purchase request, and then it immediately replies to the client with an accepted response. Now, since trading is a coordinator in this saga, it includes a state machine component that will decide which are the next steps and will keep track of the current step of the overall process. This state machine is triggered when the purchase requested event arrives to the queue trading is listening to. And the first step it takes is to calculate the total amount of yield required to complete the purchase. With that done, trading sends a command to the inventory microservice to grant the requested items to the specified user. Notice this is an asynchronous message, not a REST API call. After sending the message, the purchase state machine switches to the accepted state. Once inventory is done granting the items to the user's inventory bag, it publishes an items granted event, which trading is subscribed to. When trading receives this message, it immediately follows by sending a new command to the identity microservice, asking it to debit the calculated total amount of yield from the user. The state machine then switches to the items granted state. Eventually, identity publishes a yield debited event, which, after receiving it, signals trading that all the steps in the purchase operation are done, and therefore it switches the state machine to the completed state. There are of course some error scenarios to account for here, but we will take a look at those in a future model. Now, there are quite a few things to build to enable this purchase saga, but in this model we will focus on the commands and events that our existing microservices need to expose so that later on the purchase state machine can take advantage of them. This involves the grant items command and the items granted event on the inventory microservice, the debit yield command and the yield debited event in the identity microservice, and also we will make a small update to the events published by our catalog microservice so that they also include the prices of any created or updated items. Let's get started. It's time to update our catalog microservice so that it also publishes the item prices anytime an item is created or updated. So here I am in the catalog code base, and what I'm going to do is open the play.catalog.contracts directory and then head into contracts.cs. So remember that these are the contracts that we use to publish events from the catalog microservice. So let's update catalog item created so that it also includes the price. So I'm going to put every property in the next line so that it reads better. So I'll just do this. And then let's add one more property here, decimal price. I'll copy this, Ctrl+C, and I will do the same thing for catalog item updated. Next line. There. Now each of these two contracts will include the price. Let's now head over into items controller so that it can take advantage of the new property. So I'll go to play.catalog service, controllers, items controller. Here, let's scroll down into our post action, post async right here. And let's perhaps collapse this. And here is where we publish our catalog item created event, which now needs to include the price. So I'll just put this in the next line also, so it reads better. And then I'll add item.price. Copy that. So that fixes this one. And then I'll scroll down into put async. And we'll do the same thing, right? Catalog item updated. Let's put this in the next line. And then I'll do existing item.price. Okay. And that's pretty much what we have to do. The next thing is going to be publish the updated NuGet package with these changes. So I'm going to do Ctrl+J to open my terminal. And I'll switch to src, play.catalog contracts. And then we'll use the same NuGet.NET Pack instruction we've been using to create the other NuGet packages. So we'll just do .NET Pack. We need to specify a version, so we'll do -p package version equals 101, because the previous version was 100, and then the output directory is going to be // packages. Hit enter, and the NuGet package has been created. Here's the location where it's living, just next to each of our other packages. In the next lesson, we will update our common library to be able to specify the exceptions that should not be retried when consuming messages. As you may recall, our current add_mass_transit with RabbitMQ method is configured so that anytime a message can be consumed, mass_transit will retry consuming the message a few times. And we can take a look at that if we go back to our play.com code base and we go into the mass transit directory here, extensions.cs, I'll collapse this, and you go into our add mass transit with RabbitMQ method, and you look at these few lines over here. Here's what we're saying, that anytime a message cannot be consumed, we will retry 3 times and we will wait for 5 seconds between each try. And this works just fine. However, you will soon need to write a few mass transit consumers where you might need to throw exceptions that should not be retried, like the exception that we will throw when trying to debit more yield than what the user has available. So what we want to do here is add a new extension method that will allow our services to specify how exactly retries should be configured, including what to do with some specific exceptions. So what we're going to do is to extract this entire section here into a new extension method, and then we will modify it a little bit. So I'll just select this section, and then I'll click on Control Dot, and I'll select Extract Method. So that created the method down here, as you can see. And then I'll just click on New Method here. I'll do F2, and I'll rename this into using Play Economy RabbitMQ. Okay, hit enter. And so now let's look at that new method here. So this method really only invokes using RabbitMQ right now. But what we want to do here is actually to add a new parameter to this method so that the retry configuration can be specified. So I'll move this parameter into the next line. And since we want to create an extension method, I'll make it so that this is prefixed with this right there, so that we can just call configure and invoke this method. And then let's add a new parameter here, which is going to be our retry configuration. Well, an action that we can use it to configure the retry configuration. So I'll just say here action I retry configurator there, and configure retries. And let's import the missing namespace here, Control Dot, using green pipes.configurators. And so this is an action, like I said, that the service can pass in with all the configuration for the retries. Now this is going to be optional. Some methods may not need it. Some services may not need it. So we're going to say that this is going to be nullable. Okay. So what we're going to do here is modify how we specify this section here. So let me open a couple of lines here. And what we're going to do is this. If the configure retries action is null, we're going to go for the default behavior that we have down here. But if it is not, we will just use it as is. So if configure retries is null, then we will specify our action as configure retries equals, let's create a lambda here that says it's going to receive the retry configurator, and that's going to point to an actual implementation that is the one that we have right down here. So I'm going to copy this, just copy that over here, Ctrl V. So I'm pretty much encapsulating the entire method that we had down here into this variable configure retries now, because the caller did not specify it in that case. So now what I can do is instead of having that method down here, I can just remove all this, right? And then I'll just specify configure retries. And that's all it is. So with that, we have a method that our services can use to specify the configuration, the retry configuration if they want to. And then we will just use that as opposed to the default interval of 3 times and then interval of 5 seconds between retries. But for any service that is still using the previous method, that should still keep working. So let's actually go back here And let's modify this method so that the configurator can also be specified. So I'll put this down into a new line. And I'll just add the other parameter here for the configurator, just like we did in the new method. And that's going to be this line here, which I'm going to copy up here. And now let's fix how we are calling the using play economy with RabbitMQ method. So I'll just remove this line, and then since it's an extension method, I can just say configure dot using play economy with RabbitMQ, and the parameter is going to be configure retries. Okay, so now our existing microservices, which are already calling administrative with RabbitMQ, should not face any issues because the new parameter is nullable. So if they don't want to specify it, they don't have to, but if they do, they can specify the entire retry configuration that will be used over here. And one more thing, let's not forget to turn our new using play economy RabbitMQ method into a public method. So let's switch it to public so that any other microservice can actually make use of the method. So this was going to become very useful in the case of our trading microservice, because it's not that service is not going to be able to use admas transit with RabbitMQ just because of the way that it needs to configure the Saga state machine later on. Okay, and so with that done, let's open up our terminal, Ctrl J, and let's build an updated version of our NuGet package. So let's go to src play that common, and let's do .NET pack. We need to specify a version, so -p package version is going to be 104 in this case, and the output is going to go into this location. The directory is up and then packages. So I'll hit enter. And our new package has been created at this location. In the next lesson, we will update our inventory microservice so that it can grant items via asynchronous messages. At this point, we have a way to grant items to users via the inventory REST API. However, as we get the service ready to participate in the upcoming purchase state machine, we want to have a way to grant items via asynchronous messages. So let's add the required contracts and consumers to enable that. So here I am in the inventory codebase. And as you can remember, we still don't have a project for contracts for the inventory microservice. So let's add that. I'll do Ctrl J to open my terminal. Then I'll switch to the src directory. And then I'll just do .NET new class lib for a class library. And the name is going to be play.inventory.contracts. Hit enter. And the project has been created, as you can see here, play.inventory.contracts. Now, before we start working on this new project, let's make sure that the inventory service has a reference to the contract project. So let's go back to the terminal, and I'll switch into the play.inventory.service directory, and then I'll do .NET add reference, go up one directory, play.inventory contracts, play.inventory contracts csproc, hit enter, and that adds the reference. Okay, now let's close this terminal and let's go into this class1.cs file. So let's just repurpose this file. Let's name it contracts. And inside it, let's remove this class declaration. Let's also collapse this for now. So here we're going to define first two messages. There are going to be one for granting items. So it's a command type message to grant items, and then an event that can be used to notify that items have been granted. So let's declare this via record types as usual. So public record grant items. So we need to know which is going to be the user ID, which is going to be the item. So catalog item ID, how much quantity, so int quantity, And finally, one new thing that we need here is what we call the correlation ID. So GUID correlation ID. And the idea of the correlation ID is that this is going to be what the state machine is going to use to correlate the different messages that belong to one specific instance of the state machine. Without the correlation ID, the state machine will not know how to map the messages to the different instances of the state machine that could be happening at any given time. So all the messages to belong to one specific transaction should have the same correlation ID. Okay, so I'll just move this to the next line so that it reads better. But yeah, so that's the command type message that we can use to grant items, and we will need something corresponding to notify that they have been granted. So we'll do public record inventory items granted, and this is going to take only the correlation ID. Okay, now as we know, we may need to do compensation of this transaction in the case that some other transaction that happened in another microservice could not be completed. We'll need to subtract the items from the user, the items that were granted. So for that, let's add a couple of new messages, which are going to be structurally the same as the one that we created. So I'm just going to copy these two and paste them down here, and we're going to rename them. So this first one, instead of being grant items, is going to be subtract items. And this other one is going to be inventory items subtracted. Okay, and with that, we have our messages ready, and it's time to work on our consumers. So I'll do Ctrl+Shift+E to show our Explorer, and let's go into Play Inventory Service, into Consumers. So I'll add a new file here. So let's first work in our grant items consumer. .cs. Going to be namespace play that inventory service consumers. And let's declare our class. It's going to be grant items consumer. This class has to implement iConsumer as with every other consumer, and it's going to be of type grant items. Okay, so I'll do control dot here to import mass transit, control dot here to import play inventory contracts, and then one final control dot to implement the interface there. Now the implementation of this consumer is going to have several similarities to what we are already doing in the controller. So let's go to the controller and grab what we can from there. So scrolling down into controllers, items controller. And here the first thing we're going to grab is these two repositories for catalog items and inventory items. Just grab those two, copy, back to grant items consumer, and I'm going to declare them right here. Let's import any missing namespace, control dot, using play.common. And over here, control dot, using play inventory service entities. Okay, and now what we want to do is to add a constructor here so that we can inject those dependencies here. So let's add public grant items consumer. Okay. And now let's add both properties, both repositories as parameters into this consumer. So what we can do is just click on each of these fields, inventory items repository. I'll do control dot, and what I'll do is say add parameters to grant items consumer. So click on that, and as you can see, the new parameter has been added, and not only that, it is also being initialized right there. We'll do the same thing with catalog items repository, control dot, control dot, and then we'll do add parameters to grant items consumer there. So dependency injection is done. And now let's focus on the consume method. Same as before, let's go to items controller and let's see what we can grab from here. we're actually going to grab the logic from the post async method. So I'm going to grab most of the code from here, except for the last line. Yeah, that's going to be it. I'll just copy this into grant items consumer, replacing this one line, Control V. And now let me collapse this to see better. Okay, now here, first thing to do is to turn this into an async method. And here, we're not going to be working with a DTO, but with a message. So let's grab an instance of that message here. So let's do var message equals context.message. And then before trying to work at all with this message, let's make sure that the item that we're going to grant actually exists in our local database. Otherwise, we're going to just fire an exception, because we should not be granting an item that does not exist at all. So what we're going to do is just say var item equals await catalog items repository get async, and then we'll do message that catalog item ID. And then we check if item is null. It means that we don't have that message available, that item available in the inventory microservice. So in that case, what we're going to do is to just throw an exception, right? Let's call this one throw new unknown item exception. And we're going to pass in message that catalog item ID. And of course, this is a brand new exception. This is really customized for our case, so it doesn't exist. So what we're going to do is just do control dot over here, and we're going to pick the first option. Generate type unknown item exception, generate class unknown item exception in new file. So click on that. And as you can see, it created a brand new file over here with our new exception. Now let me place this file in a better location. So I'll do Ctrl+Shift+E to show the Explorer. And what we're going to do is just create a new folder here called exceptions. And let's move that file over there, right, into exceptions. Let's also fix a namespace. There's going to be play inventory service exceptions. And then the scaffolding did generate the most proper way to declare an exception. But for our case, it's really a bit overkill. We don't need that many constructors. So we're going to focus really only on the very first, well, the second constructor that we have over here. So I'm going to get rid of the first one there, and these other three constructors we're not going to be using. Okay, and instead of having this field over there, we're going to declare just one simple property. It's going to be type GUID, and it's going to be item ID, and only with a getter. And we remove this field. And what we're going to do is first, when we receive this catalog item ID, which we're actually going to rename into, let's do F2, and let's rename this into just item ID. Okay, and then we're going to invoke the base constructor right here, passing in the message that we want to specify for this exception. And the message is just going to be, let's do string interpolation here, unknown item, and here we're going to put item ID. So that will be the message, and then we just assign the received item ID into our item ID property, so that anybody that receives this exception can explore what item has not been found via the property. But then we also have this nice exception message right there. Okay, and now that we have this exception, let's go back to grant items consumer. Let's collapse this again, and let's do control dot here to add the play inventory service exceptions namespace. Okay, and then if we get past that, then we will go with our current logic. The difference is that this time we're not going to be working with grant items DTO, but just with our message object that we have captured already. Okay, so what we're doing is we're trying to get the inventory item that corresponds to the specified user and the specified catalog item ID. We're going to replace this with message to here. Okay, and then again, if we cannot find the inventory item, we're going to go ahead and create it into our local inventory items collection. So let's replace this DTO references right there. And let's do control dot on this one to add the system import. Let's keep going down. So then right here, we create the item, and else we will just increase the amount of quantity that this user has for that item. And again, this should be message. Okay. And so the last thing to do here is to fire the corresponding event, notifying that the inventory item has been granted. So to do that, we'll just do await context.publish, and we will say new inventory items granted, and then we pass in the same correlation ID that we received from the incoming message. And with this consumer ready, all we have to do now is to create the corresponding consumer to subtract items, right? So let me go back to Ctrl+Shift+E, the Explorer, and this other consumer is going to be very, very similar to this one. It's just going to do the reverse operation, right? So I'll just do a copy of this, Ctrl+V, and we will rename the copy as subtract item consumer, items consumer. There, items consumer, and then let's collapse this. Let's rename the class name there and here. Let's also change the message type that this consumer is handling. It is not grant items, but it is subtract items. And I'll copy that into here in the consume method. It should be subtract items. And then let's scroll down to see more of the consume method logic. Down here. And the thing that we're going to be doing differently here is that we're not going to care too much about this scenario where we cannot find the item in the inventory items collection. If we cannot find it here, then there's really nothing to do, right? So we're going to invert this logic. We're going to say that if the inventory item is not null, we're going to run the logic that we have down here. So we're going to put that over here. So if the inventory item is not null, we will go ahead and not add, but reduce that amount of quantity from the inventory item, and then update the repository. There's not going to be an else, because like I said, there's nothing we need to do if we cannot find the item. And then finally, we'll go ahead and publish the event, which is going to be inventory items subtracted with the correlation ID. And then there are more things that we may want to do in both this subtract items consumer and grant items consumer, but we'll leave that for a future model. For now, it is time to configure mass transit to do the correct retry configuration given the exception that we are not drawing here. So the first thing we're going to do is go back to, so let's go back to Explorer, Ctrl+Shift+E, and then I'll go down into Play Inventory Service. And what we want to do is to bump the version of the play.common library. Remember that in the previous lesson, we added a couple of new updated extension methods. So we want to take advantage of those now. So we're going to bump from 103 to 104. And then I'll say restore in this dialog here, restore. And then what we want to do is to go to our startup file over here. Now collapse this and close that. And we're going to go down into our configure services method right here. And this time, instead of just using the default behavior for add mass transit with DriverMQ, we are going to add something else. We're going to specify our retry configurator. And we can do that by saying retry configurator. And then we specify our Lambda expression here. That's going to configure this thing. So we're going to say that, yeah, we want to do retry configurator, that interval, the same thing as before, right? So we try 3 times, and then between each retry, we will do time span that from seconds is going to be 5. Okay, and let's see if we're missing a namespace here, control dot using green pipes. But the additional thing here is that we want to say which exceptions we want to ignore. Remember that both in grant items consumer and in subtract item consumer, we are throwing this unknown item exception. And the thing is that if we cannot find the item, because I mean the database is saying, hey, you don't have that item available here. If we just let it throw this exception, then mass transit is going to go ahead and retry the consumption of the message once again. So it's going to come again, not find it again, and throw it again, right? And then 3 times the same thing, which is completely unnecessary because the item is just not there. So this is going to be one exception that we don't need to retry. To specify that, we want to go to a startup, and in this retry configurator, we're going to say retry configurator dot ignore, and that's going to be type of unknown item exception. And let's add the missing namespace, control dot, using play inventory service exceptions. Okay, so with that done, we have pretty much the same behavior as before, as per this line. But in addition, anytime the unknown item exception is thrown from the consumer, mass transit will not retry, it will just fail right away and move on to the next thing. And the last thing to do, since we have a new contracts project, it's time to package and publish our new NuGet package. So I'll do Ctrl J, and then I'll switch to terminal. I'll go up one directory, and then I'll go to play that inventory contracts, and then let's package this project. So we'll just do .NET pack, and the output is going to be like that, packages. So I'll hit enter, and our new package is ready in this location, as you can see. In the next lesson, we will also update our identity microservice to be able to debit Jill via asynchronous messages. Just like we did with the inventory microservice, this time we want to update the identity microservice so that Jill can be debited via asynchronous messages. So here I am in the identity code base, and what I'm going to do is just do Ctrl J to open my terminal. And let's go ahead and create that project for the identity contracts because we don't have one just yet. So I'll switch to the src directory, and then I'll do .NET new class lib -n play that identity.contracts. Hit enter, and our new project has been created, as you can see over here. Now let's add a reference from the identity service project into the identity contracts project. So let's go into play that identity service, and let's do .NET add reference into play that identity contracts, play that identity contracts.cs proc. Hit enter. Okay, so reference has been added. Let's now work on our contracts project. So let's go into class.cs. I'll collapse this terminal now. And here, let's rename this class.cs file into just contracts. Let's remove this class declaration, and let's declare our contracts. So we're going to need, just like in inventory, we need a command type message to debit Jill and an event type message to notify that Jill has been debited. So let's declare public record debit Jill. We need to know from which user, so it's going to be GUID user ID. We need to know how much, so decimal Jill, and as usual, the correlation ID. And then we are going to add a public record Jill debited event with just the correlation ID. And then, given the way that our state machine is going to be structured, there's nothing really much to do if we fail to debit yield. So we will not need a compensating transaction for the event where yield has not been debited. It's just how the logic of the state machine is going to go. So with this done, we can move forward and create the corresponding consumer. So let's go to play that identity service. Let's right click and add a new folder called consumers. And then let's add a new file. It's going to be debit yield consumer.cs. Declare the namespace. Play that identity service that consumers. Declare the class debit yield consumer, which implements iConsumer and is of type debit yield. Let's import the missing namespaces, control dot using mass transit, control dot using play.identity.contracts, and then one control dot additional to implement the interface. Let's do implement interface right there. Right, and now let's work on this consumer. So let's collapse this, and then the main thing that we're going to need here to work with is our user manager instance. So let's go ahead and declare that as a field. So private is going to be read-only user manager of type application user manager. Okay, so using Microsoft ASP.NET Core identity is what we're missing, and using play.identity.service.entities. All right, and so we need to make sure that we inject an instance of this into this class. So what I'm going to do is just select user manager. I'll do control dot, and then I'm going to use this method here, generate constructor debit yield consumer user manager application user. So I'll click on that, and as you can see, that generates a constructor for this class, injecting user manager and assigning it to the field that we had already defined. Okay, now going down into the consume method. First thing we're going to do is to capture the instance of the message. So we're going to say message equals context.message. Then we're going to try to find this user in a local users collection. So var user equals await. And by the way, of course, let's not forget to make this method async. There it is. Then we'll do await user manager, but find by ID async. And then the ID we're going to get from the message. So message that user ID to string. And then if we can't find the user, then we have a problem. We can't debit a yield from this user. So we're going to throw an exception. So if user equals null, we're going to throw a new unknown user exception with message.user ID. Okay, and so this exception does not exist yet, so we're going to generate it. So I'm just going to step in here. I'll do control dot, and I'll select generate type unknown user exception, generate class unknown user exception in new file. So click on that. The file has been generated. Let's move it to a proper location. So I'll do Ctrl+Shift+E to show my Explorer. We don't have an exceptions directory yet, so I'm going to add one. Exceptions. Okay, and that's where I'm going to move unknown user exception. Move it in there. And then let's fix a namespace. So that is play identity service.exceptions. And then let's remove what we don't need from this exception. So you're not going to be using this first constructor, and we're not going to be using all these other three constructors at the end. So we'll stick with this second constructor right here. We're going to remove this field. And then we're going to say for our base for our base constructor, we're going to say just unknown user, and then we'll say user ID, which gives us a nice message in there. But then let's also add a property. It's going to be GUID user ID with just a getter type of property, so that we can assign that user ID into that property. So this that user ID equals user ID. Okay, so that sets the exception ready. Let's go back to debit yield consumer. Okay, let's collapse this and let's fix a namespace, control dot, using play.identity service exceptions, right there, scrolling down, and then let's keep moving forward, right? So at this point we have found the user, so it's time to just reduce the amount of yield that he or she has. So we'll say user.yield minus equals message.yield. But there's a thing here that we need to check. If that yield is now a negative number, right, less than 0, it means that this user actually doesn't have enough yield for the amount that has been requested. So if that happens, we actually have to stop things right there by throwing another exception, so that the caller knows that there are not enough funds, available. So we'll say if user.yield less than 0, we will throw a new insufficient funds exception with message.userid and message.yield, right? And again, this is an exception that we don't have yet, so I'll do control dot here, and I'll say generate type insufficient funds exception, generate class insufficient funds exception in new file. There. So here's a new exceptions class. I'll open up Explorer to also move this exception to the location where we have our exception so far, right there. We will fix the namespace, and same as before, we're going to remove all these first elements. We'll just leave that second constructor and then get rid of the rest. Okay, right there. Okay, and so let's see, in this case we want to have two properties here. Going to be prop GUID user ID, it's just a getter, and then we're going to say it's going to be a decimal. It's going to be yield to debit, and again it just has a getter. And then for the message, the message is going to be, well, we will say again string interpolation not enough yield to debit. Let's rename this parameter here yield into yield to debit. Okay, so it's going to be to debit yield to debit from user. Let's put it right here, user ID. Okay, that will give us a nice message for this exception, and then let's just assign the properties from the parameters. All right, so our exception is ready. Let's go back to debit yield consumer and collapse this once again. Okay, so if we get past that, we know that we are good to go with this operation. So we can say await user manager that update async user. That performs the database update. And finally, we will say we need to publish an event notifying that the yield has been updated. So await context that publish new yield debited, and then the message that correlation ID is the same correlation ID we got from the original message. All right. So with that done, we need to also do some setup for mass transit and traveling queue in this project, because we have not done that before for identity. So I'm going to do Ctrl+Shift+E to open the Explorer, and let's head into our app settings.json file. Settings.json, And here we're going to add our RabbitMQ settings section, which we are using in every other microservice. So we will say RabbitMQ settings, just under MongoDB settings, just to follow the convention, but you could put it anywhere else if you wanted to. I'll do comma here. And the only thing that we need here is the host. So host is going to be localhost. And then since we are dealing with app settings files, let's also head into app settings.development.json and modify the default log level into debug, just so that we can see the mass transit messages as they come in. Okay, now it's time to head into startup, but before doing that, let's make sure we have the latest version of our common library here. So I'll go into play.identity.service.csproc, and I'm going to grab, I'm going to go to this line, play.common, and we're going to bump it to version 104. So let's restore dependencies. And now let's go into our startup file. Let's collapse this and collapse that. So let's go into our configure services method right here. And so perhaps let's just do this just before doing the identity server configuration. So let's say services, add mass transit with RabbitMQ. And then just like we did with inventory, let's specify a retry configurator. So we'll do retry configurator. We'll specify our lambda expression here. Save this, that. Let's see if we're missing a namespace. Control dot, using play.common.mass_transit. There. Oh, sorry. And so again, let's specify the retry interval. So we'll do retry configurator dot interval. It's going to be again just 3 and with a time span of 5 seconds. So we retry 3 times and 5 seconds between each try. Let's also add using green pipes. And then as you saw, we created 2 new exceptions. Let's go back very quickly to that consumer, DBT consumer. So we know that if we can find the user, we throw an unknown user exception. And if there's not enough yield, we throw an insufficient funds exception. So both exceptions are very valid. And if they happen, it means that there's no need to retry the operation here. So we want to tell mass transit that we should not retry in the case that any of these happen. Otherwise, it's kind of a waste of time. So let's go back to startup. And let's say retry configurator that ignore type of unknown user exception, and let's add our control dot using play identity service exceptions space, and then I'll just copy this line down here, and then instead of unknown user exception, this is going to be insufficient funds exception. Okay, and so with that, identity is ready to go. And the only last thing is to make sure that we publish our new play identity contracts NuGet package. So I'll do Ctrl J to open up my terminal, switch to the terminal tab, and then I'll go up one directory, and then I'll go down into play.identity.contracts, and I'll do .NET-PACK -o / packages. Hit enter. And we have our brand new play.identity contracts NuGet package in this location. So now all the participants of our purchase state machine are ready to go. So in the next module, we will start building our actual trading microservice with the purchase state machine. In this module, you will implement the purchase orchestrated saga by creating a mass transit state machine and a new microservice. By the end of this module, you will have a solid understanding of the following: how to create a state machine using mass transit, how to use MongoDB to store the machine state, how to create an ASP.NET Core controller to trigger the execution of a state machine, how to query the current state of the state machine, how to create a custom activity that can be used within the state machine, and how to send asynchronous commands from the state machine to communicate with other services. Just to recap, in the previous module, you prepared the existing microservices to take part in the purchase saga. In this module, you will build a new trading microservice whose main responsibility is to drive the purchase saga by using a mass transit state machine. Let's get started. It's time to spin up a new project for our trading microservice. Just like we did with our previous microservices, we won't create a new project from scratch, but instead we will use the started project files I have attached to this lesson in the play.trading.start zip file just under this video. Please download the zip file and extract it into a location in your box. As you can see, I have already downloaded the file right here, and I'm just going to go ahead and right click and extract all the files. So let's just click on extract. Okay, so it's right here. I'm going to delete the zip file, no longer needed, and then I'm going to just rename this directory into just play.trading. So from here on, this becomes the directory where we're going to work in the new trading microservice. So I have also prepared a brand new instance of Visual Studio Code over here. And what I'm going to do is just click here in the Get Started page. I'm going to click on Open Folder. And I'm going to go into my D drive in my Projects folder right here. I'm going to go into our new Play.Trading directory and I'll click on Select Folder. Okay, so this opens Visual Studio Code in the context of our new Play.Trading folder so that we can work in the trading microservice. And right away, Visual Studio Code wants to restore all missing dependencies. So let's click on Restore. And now let me close this terminal here. And let's see what we got on the left side. And let me also close this Get Started. So what you're going to get here is pretty much exactly what we got both with our identity and inventory microservices. So it's the same initial structure. But as usual, the only thing that's different is if you go into Properties, into Launch Settings.json, you're going to see that we have a couple of new ports. So over here, you're going to notice that we are using port 5007 for HTTPS and port 5006 for HTTP. Like I mentioned last time, we cannot reuse the same ports as any other microservice in your local box because that's going to cause conflicts, right? So just make sure that you're using a different port here or a different couple of ports from the other microservices. All right, so now let's close this and close that. Now let's expand this a little bit so we can see all the files. Now, as we said before, we will orchestrate our purchase saga via a mass transit state machine. This state machine will keep track of the current state of the process and will drive the process from start to finish. I'm going to open my terminal by doing Ctrl-J. And then first thing we need to do is to add the mass transit NuGet package because it contains the classes that we need to define a state machine. So I'm going to go into src, play.trading.service, and then I'll say .NET add package mass transit. Enter. Right, and with that done, I'll go ahead and close terminal. And now let's define a directory where we're going to store our state machine files. So I'm going to right click in play.trading.service, new folder, and we'll call this state machines. In this directory, we're going to right click and say new file, and we will name this purchase state.cs. The purpose of this class is to represent the current state of the state machine. So, and here's where we're going to put a bunch of properties that we're going to be filling as the state machine moves forward. So let's declare a namespace. It's going to be play.trading.service.state machines public class purchase state. Okay, and the first thing to do with this class is to make it implement the correct interface. So that will be Saga state machine instance, and I'm going to do control dot to use automatonymous. And we need to implement this interface because really each of these sagas are going to actually turn into instances as we drive each of our purchase processes. And so anytime we start a purchase process, a new instance of the purchase saga is going to be created. Now, if you do control dot in these red squiggles, we can implement the interface. And you're going to see that the main thing that you need in a purchase, in a state machine instance is the correlation ID. This correlation ID is what uniquely identifies each instance of our state machine. And in our case, we're going to say just public GUID correlation ID, and we're going to define it as with the get and with the set, just like this. Okay, so that's the main thing to define here. The next thing is going to be the current state. So prop string current state, and just remove that line. And so the current state is, well, as it says, the state in which we are in the state machine. So if we are accepted, or if we have granted items to the user, or if we are completed, we'll define those states later on in the state machine. But this is where we will store them. Next thing is the user ID. So GUID user ID. So which is the user for which that's triggering or is requesting this purchase. The next one is going to be GUID item ID. So this is the item that we're trying to purchase, right? Next one is going to be an int, and this is the quantity. So this is how much of a specific item we are trying to purchase. The next one we're going to define here is a date time offset. We're going to call it received. We're only going to be using this one to keep track of which is the time, date and time, when we receive the request for this purchase. Next, we're going to define a decimal, a nullable decimal, which is going to be called purchase total. And let me scroll down a bit here. Purchase total is the property where we're going to store the calculation of the total amount of items, so the quantity amount multiplied by the price of the item that is going to be purchased. That's so that we later on know how much to debit from the user's wallet. Then it's going to add another date time offset. We're going to call it last updated. And this is just to keep track of each time we touch the state machine. We will also set this last updated just so that we know when was the last time that the state machine received an update. Here we'll also add another one, which is going to be public string error message. And this is going to become handy so that we can store any error message that happened as we were processing the state machine. Right, so that then we know what actually happened. And that's pretty much what you need, what's going to be needed for our state machine. Now, the only additional thing that we need in our specific case, just because we will be using MongoDB to store the actual state of the state machine, because the state machine will become a document in database, is that we need to implement another interface that's called iSaga version. iSaga version. And then I'm going to do control dot and say using mass transit.saga. Okay. And then I'm going to do control dot again to implement that interface. And as you can see, what this new interface demands is that we implement a version field. So basically this new field is this version field or property is used for optimistic concurrency as we store data in the state machine only for MongoDB. And just like we did before, I'm going to just remove this piece, and that should be it. So those all the properties that we need to define for the state of our state machine. Now it is time to define the actual state machine. So I'm going to right click on state machines. I'll say new file, and then we'll name it purchase state machine.cs. So let's say namespace play.trading.service.state machines. Let's declare our class purchase state machine. And this one needs to inherit from mass transit state machine of type of the class of our state, where in this case is purchase state. Right, so let's make sure we do control dot to import automatonimus, and that will do it. And the main thing that we're going to define here is the actual states, right? So we're going to have 4 states in here. So let's define prop state accepted, with a getter. Next one's going to be state items granted, again just with a getter, to prop g, and then we'll say state completed, yep, only a getter. And the last one is going to be the state for the case where we fault, or when we have some issue across a state machine. So it's going to be prop state faulted. And so you're going to see how, as we build this state machine, we go from one state to the other, depending on the actions that are needed at each step. And the last thing that we're going to define for now is a constructor. So I'll just do here control dot, and I'm going to pick generate constructor purchase state machine, which is right there. I'll actually put this constructor down here. And then the way we can tell mass transit which is going to be the current state is by using the instance state method here, to which we need to pass an action where we pass in state, and this takes us to state.current state. That's how we define where is that we're going to keep tracking the state, right? And one last thing to do here is to make sure that we turn this constructor into a public constructor, not protected, so public, so that the dependency injection engine can properly find it and instantiate it when needed. In the next lesson, we will see how to initialize the state machine. In order to initialize our state machine, we will need to tell it which is the event or message that triggers a new state machine instance. So let's go ahead and define this message. So what I'm going to do is just right click in play.trading service, and I'll say new file, and let's name it contracts.cs, which is very similar to what we have done in previous microservices. It is just that we will not place this file in its own project because there's no need to package it as its own NuGet package. There's not going to be any other service consuming these contracts. So now let's define the namespace as play.trading.service.contracts. And let's define our record type for the message. Since this is the message that's going to be requesting a brand new purchase, we're going to name it purchase requested. So public record purchase requested. Okay, let's open up new line. So the first thing that we're going to need to request a purchase is the ID of the user. So user ID, I'll do control dot to use using system. Next thing is going to be the item ID, which is the item to be purchased. Then int for the quantity, which is how much of that item we want to purchase. And finally, a GUID for the correlation ID. This correlation ID is what is going to signal our state machine that it is time to initialize a brand new instance of the state machine, because this is a brand new message, right? It's a unique correlation ID. And we'll see later how we come up with a correlation ID for this message. And now that we have that, it's time to go back to our state machine and start making use of this new message. So we'll go to purchase state machine.cs. I'll collapse this. And the first thing to do here is to declare that message as an event. That's how you define an event in a mass transit state machine. So let me scroll down a bit, and I'll define public event purchase requested, which is just going to have a getter like that, and like this, and then let's make sure we do control dot here to import the play.trading.service.contracts namespace. So that's how you declare the event in this class. But we need to also configure it properly so that mass transit can make use of it. So to do that, I'm going to open up a brand new method down here at the bottom. Let's call it private void configure events. Okay, just to keep things a bit more organized. And here, the way that you associate an event with the state machine is by using the event method, which is going to receive a lambda expression that you can use to configure the event. And our event here is just purchase requested. Then let's make sure we call this method from our constructor. So after instance state, we're going to call configure events. And now it is time to actually configure the initial state for the state machine. And to do that, we're going to open up yet another method down here. Here, let's call it private void configure initial state. And I'm going to scroll down a bit to make some more space. And here we're going to be using the initially method. I'm going to open up there. Okay. And so here's where we have to say what should happen as the state machine gets activated, as a new instance gets created. So we have to say first what is going to trigger the new instance, and that's going to be our purchase requested event. So we're going to say when purchase requested dot, then what do we have to do? So here we define another lambda expression where we receive a context. This context is what's going to provide us access to the instance of the state machine. And we'll say lambda expression right there. And here is our first chance to do something about the state of the state machine. So what we're going to do is to capture a bunch of properties to start keeping track of them in the state. So we're going to say context that instance, so where instance is the instance of the state machine, and then user ID is going to be context that data, where data represents the incoming message, right? The purchase requested message, that user ID. So that's how we keep track of the user ID. And then we'll do something similar. Context instance that item ID equals context that data that item ID. Same thing for the quantity. Instance that quantity equals context that data that quantity. And then we're going to capture context that instance that received. And like I said, this is just a kind of a timestamp of the current time when things started for the state machine. So this is going to be date time of set. Let's add using system date time offset dot UTC now. And finally, we'll set the other kind of a timestamp context that instance that last updated, which is the last time this state machine got touched in some way. So context that instance that received. Okay, so this means that, okay, so whenever we receive the purchase requested event, then we should go ahead and capture all these properties. And then what? So after that, we need to set what's going to be the current state of the state machine. So the current, to do that, we're going to just move to the next line and say dot transition to accepted, where accepted is our first state. And this is how you can go ahead and initialize a state machine. I think I'm missing, it should not be there. And now let's not forget to invoke this method from the constructor. So let's go up into our purchase state machine constructor and let's invoke configure initial state. In the next lesson, we will add a controller action that can publish the event that starts the state machine. Now that we have our purchase state machine, let's define an ASP.NET controller and the corresponding action and DTO that can trigger it. So as we have done in other microservices, we're going to just right-click at the root here, I'll say new file, and we're going to define our DTOs file. So DTOs, that's yes. And let's define the namespace as play.trading.service.dtos. Okay, remember our DTOs are just record types. And so the DTO that we're going to define here is going to be named submit purchase DTO. So public record submit purchase DTO. Going to a new line. And here we're going to define two things. First thing is going to be the item ID. So it's going to be a GUID item ID. So let's import the missing namespace using system. And the next thing is going to be the quantity, right? So how much of this item we need? Quantity. Okay. Now we also want to make sure we apply the corresponding model validation to these two properties. So for the item ID, we're going to say that this is required. There has to be an item ID, and I'm going to do control dot here to use system component model dot data annotations. And also, by the way, just by setting required here doesn't by itself enforce that a valid item ID or GUID needs to come in here. And this is because GUID is a structure and not a nullable type. So to make sure that it really has to be a valid GUID and not just 00000, we're going to make this one nullable with this question mark there. Okay. And then next thing is that for the quantity, we'll define a range here. We'll say that the range is going to be from 1 to 100. Okay, that's as much quantity as somebody can request in a single purchase. And with this defined, it's time to define now our controller. We'll go to our controllers directory over there, right click, new file, and let's name this one purchase controller.cs, copy the name. Let's define our namespace, which is going to be play.trading.service.controllers, and then public class purchase controller. Let me collapse this for now. And as with any other controller, we have to make it inherit from controller base. And now I'm going to do control dot to use Microsoft ASP.NET Core.MVC. And then let's make sure we define the basics for this controller as attributes here. So the main thing is turning it to an API controller. We also want to define the route, the main route for the controller, which is going to be in our case just purchase. And lastly, one more thing we want to do here is to make sure that we add the authorize attribute, and I'll do control dot using Microsoft.ASP.NET Core.authorization. And so this is key so that we can easily tell which is the user that is invoking our post action that we're going to define in a moment, right? We're not going to be asking the user to pass in the user ID as part of the body of the request. We are actually just going to read it directly from the authorization context. Okay, so now let's go ahead and define the things that we need for this controller. First thing we're going to need is our iPublish endpoint, the mass transit publish endpoint, so that we can easily publish the message that is going to trigger the state machine. So I'm going to define private read-only iPublish endpoint, publish endpoint. Okay, and I'll do a control dot here, control dot using mass transit. Okay, now we need to do dependency injection for this one. So what I'll do is I'll just click on publish endpoint. I'll do control dot, and I'll say generate constructor, purchase controller, I publish endpoint, right there. So the publish endpoint is getting injected into this class now. So now we can define the actual post action. So let's define this as public async task of I action result, post async, and this is going to receive our submit purchase DTO. Let's call it just purchase. All right, and let's make sure first thing is make sure we define this as with the post verb. So HTTP post. Then let's import the namespace for task, which is going to be system.reading.tasks. Okay, keep going down. Let's also click control dot here so that we can import play.trading.service DTOs. Okay, and now the first thing that we want to do here, like I said, is to figure out which is the user that's starting this purchase. And we can do that just by getting it from the authorization context. So I'll do var user ID equals user dot find first value. And here we're going to be using the claim that's named sub. Remember that sub is what includes the user identifier. Now let's see what we're missing here. I'll do control dot, and we're missing system.security.claims. Scroll down. Now, as you remember, for our purchase requested message, we need a correlation ID. So we're going to define it right here as saying var correlation ID equals GUID.newGUID there, and let's import the missing namespace using system. And then keep in mind that as with everything else we do in this course, things will keep evolving over time, right? So the fact that we're defining the correlation ID here is just kind of a temporal thing to get things going. And later on in the next module, we'll see if this is actually a good idea or what can we do better about this. But for now, this will work just fine. So now we are going to define the actual message that we're going to send. So we're going to say var message equals new purchase requested. Okay, we're going to open up that. Let's see control dot here using play.trading.service contracts. And so here we need to provide the values, right? So first is going to be the user ID, which we need to parse into a proper GUID. So we'll say GUID.parse, and that's going to be user ID. Then we need the item ID, so it's going to be purchase.itemid.value. Then we have the quantity, purchase.quantity, and finally our correlation ID. All right, scrolling down a little bit more. Now we can go ahead and publish this message. Then we will just say await publish endpoint that publish, and here comes the message. And after doing all that, we're going to say, okay, so return accepted. So as you can see, we receive a purchase request in this post method. We extract the user ID from the authorization context. We generate a brand new correlation ID, construct the message using what we received plus the user ID and plus the correlation ID, publish that, and then we just return right away accepted to our client. So that way our client doesn't need to be waiting for our state machine to do the entire process. So we just say, hey, accepted, and then later on we'll figure out a better way to tell it how to keep track of the state machine. In the next lesson, we will add the required configuration to be able to run the state machine for the first time. Let's now add the proper startup configuration to the trading microservice so that it is ready to receive requests and also to enable our state machine to start interacting with MongoDB and RabbitMQ. So first we're going to go into our app settings.json file, and here's where we have to define the typical configuration we have done in previous microservices for the name of the service, settings for MongoDB, and for RabbitMQ. And since this is pretty much the same thing we've been doing in other microservices, what I'm going to do is just grab it from the catalog microservice in this case. So I'm going to open up the catalog code base right here. And I'm going to go into app settings.json, and I'm going to copy these 3 sections here. I'll do copy, and then back into play.trading. I'm going to just open up a section here and Control V to paste it. And of course, the one thing that we have to change here is the name of the service. This case is going to be trading. And remember that this is what defines the name of the database in MongoDB. And also, just like we did for the other microservices, we're going to go into app settings.development.json and define the default log level as debug, just so that it is easier to track what's going on with the mass transit messages. The next thing that we need to do is to add a few NuGet packages so that we can use a few required classes in our startup class later. So I'm going to just go ahead and do Ctrl J to open my terminal. I'll switch to src play.trading.service, and then I'll do .NET add package play.common. Remember, this is where we have all of our common libraries, which include methods for MongoDB, RabbitMQ, and authorization. Then we will do .NET add package mass transit.ASP.NET Core. Then we will do mass transit.RabbitMQ. And finally, mass transit.MongoDB, which is going to allow us to define MongoDB as the database behind our state machine. Okay, so with that done, I'm going to close the terminal, and then I'm going to go into our startup.cs file. And I'm going to collapse this. And here what we're going to do first is to go down into our configure services method so that we can initialize our Mongo services. So I'll just open up another line here and I'll say services.addMongo. Okay, and let's make sure we do Ctrl dot to import play.common.mongodb. And we're doing this mainly here to take advantage of how that method will change how both the GUIDs and the datetimes get serialized into MongoDB. But also in future lessons, we will be adding a few specific repositories that will take advantage of this. The next thing, which I'm going to add in the next line, is to configure authorization and authentication. So for that, we're going to be using our add JWT bearer authentication method, also from our common library, for which I'm going to do Ctrl dot using play.common.identity. Okay, and remember that we need this because we want to get the user from the authorization context back in the controller when he posts a purchase request, right? And if we are doing this, remember that you also always have to complement that with a line in configure, just between use routing and use endpoints. You have to add, and I'm going to add it right here, our app.use authentication call here. If you don't do this, then authentication is not going to work properly. The next thing is to define the actual method where we're going to configure mass transit. So that one we're going to add down here as a new private method. It's going to be private void add mass transit. It's going to receive the service collection services. Scroll down here. And here what we're going to do is call services.addMassTransit. And we're going to pass in the configure object that we're going to be using to configure all the mass transit services inside. Let me go back here and I'll do Ctrl dot to use mass transit. And let's make sure this is lower C, not capital C. And then let's use that configure object to invoke our new using play economy RabbitMQ method. And I'll do Ctrl dot here to do using play.common.mass transit. Remember, this is the new method we added into the library, and this allows us to configure specifically the RabbitMQ part. In this case, where we cannot just use the other add mass transit with RabbitMQ method, because we're going to add some Saga specific configuration here. So that's why we cannot use the method that we've been using in the other microservices. So in the next line, we're going to call configure.addSagaStateMachine. And we need to pass two types here. The type of a state machine itself, which is purchase state machine. And then I will control dot here to import play.trading.service.state machines. And then purchase state, which is the actual state, right? And after doing that, I'm going to do dot, and then we're going to say MongoDB repository. And this is because we need to inform the state machine that we're going to be using MongoDB in this case to store or to persist the state. So for this one, we're going to open parentheses. We'll use R for repository, and then let's add another lambda expression here, which I'm going to close right there, to do the repository configuration. So before we can configure the repository, we're going to need to know the connection string and the database name for the repository. We're going to grab this just like we did in previous cases. So we'll do var service settings equals configuration get section. It's going to be name of service settings. We'll do control dot here, and let's do play.common.settings, and then we'll do get of type service settings, like that, to cast it properly into the variable. And perhaps I'll move it into a new line so that it reads better. So that will give us the service settings, and then I'll just copy these two lines to the next line so that we can retrieve the MongoDB settings. So this is going to be Mongo settings equals configuration get section MongoDB settings. Okay, casted as MongoDB settings. And with that in place, we'll just go ahead and set r.connection equals MongoDB settings. MongoDB settings Mongo settings that connection string, and then r.database name equals service settings dot service name. So that sets up the repository as MongoDB repository for the Saga state machine. And then the last thing to do here is to add the mass transit hosted service. So we'll do services.add mass transit hosted service, which, as you may remember, is what we need to open up the bus that is going to, through which the messages are going to go. And with that done, let's go back to our configure services method. Let's make sure we invoke that add mass transit method that we just created, passing in the services collection. Okay, and that's pretty much what we have to do on the side of trading. But as you may remember, each of these microservices need to be configured in the identity microservice so that identity server can properly manage the authorization for each of them. So let's head into the identity microservice and add the proper configuration. And here I'm going to head into play identity service, and then I'm going to go into app settings.json. Here I'm going to scroll down into the identity server settings section. So as you remember, here's where we have defined all the scopes, API scopes available across the system. And so here's where we're going to add one new scope to get access to the trading APIs. So I'm just going to copy this one here, and I'll add it just here. And let's call this one trading.fullaccess. Of course, you can do any other kinds of scopes over here, but let's just keep it simple and let's add one scope for full access for trading. And just like we did that, we need to scroll down here into the API resources section. then we need to declare trading as a new API resource. So I'll copy the section again for inventory, and I'll put that down here. There. And we're going to rename this one to trading. And the scope that's going to use is the one that we just declared, which is trading.full access. And it is also going to expose the role claim. And one last thing, remember that we need to also say that our Postman client is able to make use of this new scope. So let's go into appsettings.development.json, and let's scroll down into the Postman section over here, not the front end, the Postman section. And let's head down over here where we have the allowed scopes. And I'm going to copy the inventory scope once again. And just down there, I'm going to add the trading.full access scope. In the next lesson, we will post a purchase request to our controller and trigger the purchase state machine for the first time. It's time to send our first purchase request to our trading microservice and see our state machine working for the first time. So here I am in the identity code base, and I'm just going to go ahead and open my terminal via Ctrl+J, and I'll switch to src play.identity.service, and I'll just do .NET run. Enter. Okay. And then the other microservice we're going to need is the catalog microservice. So I'm going to open up that one now. Okay. And we're going to start this one just because we're going to be querying the existing set of items now from Postman. So let's go to terminal and then src play.catalog.service and .NET run. And finally, let's head back to our trading microservice. And in this case, let's put a couple of breakpoints. So I'll open up my Explorer via Ctrl+Shift+E. I'll go to controllers, purchase controller. And let's place perhaps a breakpoint right here, just to inspect what is happening over here. And let's also go to the state machine, purchase state machine, and into the configure initialize method right there. Okay, and so with that, I'm going to collapse this, and I'll do F5. Okay, let's see, it's all up and running. And now it's time to go into Postman so that we can do the purchase operation. But before doing that, let's remember which are the available catalog items. So here I have my 3 Postman collections, and then I'm going to open up the catalog service collection for the items route, and then I'm going to go into get items. And first thing is going to be to get a token, right? We don't have a token right now. So let me scroll down here and say get new access token. Opens our familiar page here. Let's access as admin so that we can query the catalog. Admin.play.com. I'll log in, proceed, and this is our admin token. I'll say use token. And now we can go ahead and do the get operation to get items. So I'll hit send. And sure enough, here they are. So right now what we have is a potion, an antidote, and a high potion. Okay, so now that we know that, let's say we're going to go for the potion. So let's open up a new tab here, and let's put the route into our trading REST API. So let's head back quickly to VS Code to remember where is this REST API being hosted. It is right here. It says now listening on this URL. So it's port 5007. I'm going to copy this, and then I'll go back to Postman, paste it here. And remember that our controller is actually going back again here into the, scroll down a bit, and I'll open up Ctrl+Shift+E just to see our purchase controller for a second. Remember that our route is purchase. So I'm going to copy purchase, copy that, then I'll collapse this one, back to Postman, and then we'll say /purchase. Also remember that we're doing a post operation, not a get operation, so I'll switch this to post. Then let's head to the body, and we'll say raw, and then it's going to be JSON. So make more space. And so what we put here, let's go back again to trading. And let's remember what is our DTO for the post submit purchase DTO. So we're going to need item ID and quantity. Okay, so let's head back to Postman. Let's open up a JSON section. And so item ID. And here's where we're going to need the actual item ID. So going back to the get tab over there, let's grab the item ID of the potion. So I'll copy this back here, and then I'll paste that. And then we'll say quantity is going to be 1, just 1 potion. Okay, and with the body defined, what we need now is authorizations to be able to call the purchase operation. So let's go to authorization and let's switch this into OAuth2. And then let's see, let me scroll down this a bit. One thing we're going to need here is to expand the set of scopes that we're using, because as you can see, it is remembering most of the parameters, Postman, but it doesn't know about our new scope. So we need to request access to our trading scope. So I'm going to use copy inventory there, and I'll add right here our trading.full access scope. And now that we have the scopes ready, one more thing that we have to do here is to get a new access token. We already got one for admin, but we don't want to use this admin one because we want to perform the purchase in the context of an actual player, right? A player wants to go ahead and purchase an item, not an admin. So let's go ahead and get another token. I'm going to scroll down. I'll click on get new access token, and I'll go ahead and say player1 player play.com. Hit login, proceed, and let's name this one player1. I'll say use token. And now I'll go ahead and hit send. And sure enough, if we go to Visual Studio Code once again, we can see now that a breakpoint has hit. We were able to retrieve the user ID from the subclaim from the user object. We got our brand new correlation ID, and our message has been constructed with everything that's needed to initiate a purchase. So I'll go ahead and click on continue. And now we are in the purchase state machine. We're in the configured initial state where the breakpoint has hit. And here you can see that we have received the message in this data object that includes everything from the correlation ID, item ID, quantity, user ID, everything is there. And that is going to be now stored into the state machine instance state, which right now it is pretty empty, although it does have an initial state here, which is going to change in a second, but everything else is pretty much empty. So now I'll hit on continue, which should have made the state machine to transition into the accepted state. So let's now confirm a few things here. So let's go back to Postman and let's just configure that we got a 202 accepted response, which is what the client is expecting. So that's fine. Now let's see, just to understand a little bit better what happened in RabbitMQ. So if you go back to RabbitMQ in localhost in port 15672, I'm going to go as guest. I'll do login. And here what you're going to see if you go to queues is that there's a new queue here called trading purchase state. This is the queue that is packing up the state machine. So every single message that we publish from our controller to initiate the state machine instance is going to first land here. And from here is where the state machine is going to pull down those messages to initiate the state machine. You can also see that we already have an identity David Jill message here, which is because we started the identity microservice and it is waiting to receive messages from the state machine, which will happen in a few next lessons. And one more thing to confirm is what happened in the database. So if you go back to Visual Studio Code, and I'm going to do Ctrl-Shift-P to to do view toggle activity bar visibility, and then I'll do ... on this left side, and then I'll click on MongoDB. I'll connect to the database right there. And as you can see, we do have a trading database now. So I'll open up that, and it has this purchase.states collection. Okay, so that's the kind of default name that you would get from mass transit conventions. But if you wanted to, you can configure your own name for this database collection if needed. Now in that collection, what we're going to find is that there is one document, and if we click on it, you're going to see that this is the current state of the state machine. You can see that it has transitioned into accepted, and it has all the properties that we set: user ID, item ID, quantity, receipt. There's no purchase total yet, we have not calculated that, but then there's last updated, and the rest is null, and then 0 for version. Okay, so in the next lesson, we will add a new controller action so that we can query the state of this state machine without having to come into the database every time. Before we start adding more meaningful logic to our state machine, let's add a new controller action to our trading microservice so that we can easily query the current state of our state machine instances. So the way we can query the state of the state machine is actually by sending it an event that it can reply to with information that we want to ask from it. So for this, the first thing is going to be to go into our contracts file, and we need to add a new contract that is going to represent the message to be sent into the state machine. So I'm going to declare public record get purchase state, and the only thing we're going to send here is the correlation ID. Remember that the correlation ID is what uniquely identifies one of our state machine instances. With that in place, it's time to go to state machines, purchase state machine, and we need to add this event to the state machine, basically. I'm going to collapse this for a moment. I'm going to go up, and just next to our other event, we're going to declare public event of type get purchase state, get purchase state. Okay, with a getter right there. Okay, and just like we did with the other event, we're going to go into the configure events method, and we are going to do the same thing. We're going to declare an event, and the lambda expression is going to point to get purchase state. Okay, so with that, the state machine is able to recognize the event, but we have to tell it what to do when this event arrives. So for that, we're going to open up another section right here. We were going to call private void configure any. Scroll down. And the reason why we call this method configure any is because we're going to say that what is going to happen here is going to apply during any of the possible states of the state machine. So in fact, we're going to say during any. Okay, so we open and close. And here we're going to say when get purchase state happens, we're going to respond with, and here's a lambda expression, x.instance. Okay, that means that it doesn't matter in what state the state machine is. If the get purchase state event arrives, we're going to respond with the entire state of the current instance of the state machine. And then one more thing, let's not forget to invoke this configure any method. Let's invoke it just after invoking configure initial state in the constructor. So let's say configure any, and there it is. So with that, the state machine is ready to retrieve the information from the machine itself back into the caller. And now it's time to prepare the input to our controller action. And that we're going to define as a new DTO. So I'm going to do Ctrl-Shift-E, and then I'm going to go into our DTOs file. Okay, now I'll collapse this again. And here we're going to add a new DTO that's going to represent all the information that we are going to retrieve from the state machine. So public record purchase DTO. Okay, so first thing we want to return here is going to be the user ID. Then we want to return the item ID. Let's also return a nullable in this case, which is going to be the purchase total, because we may not have it just yet, depending on the state of the state machine. So it is just nullable. We will add the quantity, the current state. We will add a property called reason, which will be the reason why the state machine, in this case, failed, right? For any specific reason. That will give us a hint of what's going on. And then we'll also add datetime of set received, so the time when the state machine received the first message, and datetime of set last updated is the last time the state machine was modified. And with that in place, it's time to go to our controller. So I'll do Ctrl-Shift-E. Let's go into controllers, purchase controller, collapse this. And here the first thing is going to be to declare an iRequest client, a mass transit request client. That is the class that we can use, or I guess the interface that we can use to send a message via mass transit expecting an immediate response. So it's kind of a request reply option in mass transit. So to do that, we're going to declare private read-only iRequest client get purchase state purchase client. See, that means that this is a client that is able to send get purchase state messages or commands into the other side, in this case into our state machine. Let's add let's inject this purchase client into the controller by doing control dot over here, and I will just say add parameters to purchase controller iPublish endpoint, and as you can see, that has added it over there. I'll just do multiple lines so that you can see better. Yep, so it's injected and it is assigned to the purchase client field. And with that in place, we can go ahead and implement our new controller action. So this is going to be public async task of type action result purchase DTO is what is going to be returned, get status async, and this is going to receive the correlation ID. Okay, so let's make sure we add the correct verb here. So this is going to be an HTTP GET, and the route we're going to use is going to start with status, and then it's going to have to receive the correlation ID. Okay, so here's where we need to go ahead and query the state machine. Now, like I said, we can do that with the client that we just added. So the way you can do that is by saying var response equals await purchase client that get response, and it's going to be of type purchase state. Let me make sure control dot that we import the play.trading.service as state machines namespace here. Then let's open parentheses, and here's where we're going to add the message to be sent. So it's going to be new get purchase state, which is going to receive the correlation ID that we got in the parameter. Let me send this to the next line so that you can see better. So keep in mind that this looks like an asynchronous communication against a state machine, but it is in fact still asynchronous communication. It is just that this creates temporal queues behind the scenes, and the client here is actually waiting for a response from the other side, right? So imagine that a message goes into the queue of the state machine, and then the client is just waiting on his own queue for another message to come back and respond. Now that we got that response, we can get the state by saying purchase state equals response.message. So now we have our state, and now we just need to transform that state into the corresponding DTO. So we'll say var purchase equals new purchase DTO, and we'll have to do a few mappings here. So purchase state that user ID, purchase state that item ID, purchase total, quantity, the current state, the error message will go as a reason into the DTO, the receive time, and finally the last updated time. And with that, we can go ahead and just say return OK. So it's going to be a 200 OK with the purchase DTO. And since we now have this get operation for a given correlation ID, we are now able to update our post action to redirect into, well, not to redirect, but to add the location header with the correct address of the state of a state machine for the client to go ahead and query the state after posting a purchase. So to do that, we're going to go scroll down into post async all the way to the end. And I'm going to actually remove this breakpoint here. We don't need it anymore. And we're going to change this accepted action into accepted add action, as we have done in other microservices. So then we will say the action name is name of get status async. Second parameter is going to be the actual correlation ID that has to be used as an input parameter in the other method. So here goes an object, and an anonymous object here that's going to just receive the correlation ID. And lastly, we are going to provide some body for the response. We could put really anything here. I thought it would be good to just put the correlation ID back again, since that makes it easy for us to explore the results in Postman. So I'll just do that. Okay, so with that, our new controller actions are ready. And what we want to do now is to just not forget that there's a bug, if anything, in ASP.NET Core, where if you just do that and we try to invoke accepted action with get status async, it is not going to be able to match this get status async method, just because at runtime the async suffix is removed by the runtime. So we want to do the configuration to make sure that that is not removed. So to do that, let's go ahead and into the Explorer and let's switch to startup.cs over here. And we're going to go into the section where we add controllers, this line here. So we were going to add options here so that we can configure those options. And the only option is going to be options dot suppress async suffix in action names equals false. Okay, so once again, going back, if you don't do that, what it means is that at runtime, this method over here, get status async, gets transformed into get status. And when we try to do the accepted action, it just fails because it cannot find it. One last thing we have to do in startup, or I guess one more thing we have to do in startup, is to kind of optional, but we're going to have some JSON values that are going to be null initially for the state of the state machine. So we can just get rid of those so that we don't have to look at all these nulls in the responses. So to do that, I'm going to just open here, and just after the add controllers call, we can say dot add JSON options, and we're going to say options, then options dot JSON serializer options, ignore null values equals true. So if there's any null in the return properties of the DTO, those are going to be ignored. And finally, we need to modify our add mass transit method, the one that's at the very end, so that we add the actual client, so the instance of the client gets registered into the runtime so that we can use it in the controller. And to do that, we can just add one more line after the last line in this method, and we will just say services.add generic request client. So this will register every single client that we've been using across the application. Okay, so with that in place, we are ready to test this out. So to do that, first thing I'm going to do is make sure I have my identity microservice up and running. So here I am in identity. I'm just going to do .NET run, identity microservice. All right, and then back to trading. I'm going to just go ahead and hit F5. And now I'm going to go into Postman. And we're going to try out another purchase, right? So let's see what's the status of our tokens. They have expired, so I'll get a new token for our player. In fact, I'm going to delete all the tokens first, and then I'm going to say get new access token. Yep, and then I'll go ahead and log in. Proceed. This is our new player 1 token, use token. Remember, we have a body here that has the item ID and the quantity. And then I'm going to hit send. Okay, so we got our 202 accepted, but this time we got the correlation ID as part of the body as it was expected. But not only that, if we look at the console all the way down in the post action, in the response headers over here, you can see that the location is populated with the location where we can go ahead and query the state of the state machine. So if I just copy this, just copy that, and I'll close this, and then I'll open another tab here. I'll just paste it there, the get operation. And of course, we're going to need an access token to be able to talk to this API. So I'm going to go to the authorization tab. I'll pick OAuth2. Okay, scroll down a bit, and then I'll pick our player token. And with that, I'm going to go ahead and hit send. And sure enough, now we are getting the state of our state machine. So you can see we have the user ID, item ID, quantity, the state, which is the most important piece now, the state of the state machine, and then the values for received and last updated. So we no longer need to go into the database to figure out, okay, so what's the state of the state machine? We just need to query this, and then we'll get it right away. In the next lesson, we will update our trading service so that it can consume the prices of the catalog items. In order for our state machine to be able to calculate the purchase total, it needs to know the prices of the different catalog items. So let's update trading so that it can consume the item prices anytime an item is created or updated. So the first thing that we're going to need is the NuGet package from our catalog contracts. So I'm going to do Ctrl-J to open terminal, and I'm going to switch into SRC, play.trading.service, and let's add .NET add package, play.catalog.contracts, enter. And remember that this is the updated catalog contracts package that includes the prices of the items. Okay, so with that in place, I'll close this. And next thing we're going to need is entities that represent the catalog items. So I right click in the play.trading service directory. I'll click on new folder, and let's name it entities. And let's also add a folder for our consumers, because we're going to need to consume messages from catalog. So new folder, consumers. And so both the entity that we're going to need here, the catalog item entity, and the consumers that we're going to need to consume those messages from catalog are actually very similar to the entity and the consumers that we're already using in inventory. Because remember, inventory is already consuming updates anytime items are created, updated, or deleted in catalog. So to save time, let's just go ahead and copy as much as we can from the inventory microservice. So I'll go ahead and open the inventory code base right here. And first thing is going to be, let's go to entities and let's copy the catalog item class. Copy. And then back to trading, we'll just paste it right here. There it is. And then let's go back to inventory once again, into the consumers directory, and let's copy catalog. Let's expand this a bit. Catalog item created consumer, deleted consumer, and updated consumer. So we'll copy those three. I'll just close this. And back into trading, I'll just paste those three into consumers. So paste there. Now the first thing to do here is to fix namespaces. So I'll go back to catalog item.cs, and let's change it so that the namespace reads as play.trading.service.entities. And I'm going to copy the trading word also here. And the same way, we're going to go into each of our consumers and just replace inventory with trading over here and over there. here again, inventory replaces with trading, and in this last one, inventory is replaced by trading. The next thing to do here is to go back to the entity, the catalog item entity, and add the missing property. Remember that now we do have prices, so we want to track prices in the trading microservice. We didn't need that in inventory because it doesn't care about prices, but we do need that in our side here. So I'll just add our prop decimal price. Okay, so that way we can keep track of prices on this side. Now let's go into our consumers. So let's go into catalog item created consumer. Let's collapse this. And so in this case, the logic is going to be pretty much the same. But what we're going to do here in addition is to set the price, of course. So here when we are creating the catalog item, we're going to add price equals message.price. And then let's switch to catalog item updated consumer. And let's do the same. Let's scroll down. And here where we create the item, if it is null, we're going to go ahead and say price equals message.price. And also on the other side, down here, we will say item.price equals message.price. Lastly, let's take a look at catalog item deleted consumer. Let's see if we need any changes here. So yeah, in this case, if we can't find the item, it is fine. I mean, it has already been deleted, so nothing to do here. Otherwise, we'll go ahead and just delete the item from our local database. All right. So with that in place, what we need to do now is to add the proper configuration in startup so that we now have our new catalog items collection in the trading database. So I'll do Ctrl+Shift+E to go to Explorer, scroll down, and I'll go to startup and collapse this. So I'll go all the way up into our configure services method. And here I'll just going to add the typical line that we've been adding in other microservices. Just after that Mongo, we will say add Mongo repository. In this case, it's going to be of type catalog item. And the name is going to be, just as in inventory, catalog items. I'll do control dot here to make sure that we get the play.trading.service.entities namespace. And lastly, since this is the first time we are adding consumers to trading, we have to make sure that the instance of mass transit we're going to be running here is able to use all of those new consumers. And to do that, we're going to add one more line here, perhaps just after using play economy with having queue, and it's going to be configure dot add consumers, and those are going to be from our entry assembly or our courier assembly, which is assembly dot get entry assembly. And let's go back here, let's do control dot, and let's add the system.reflection namespace. So remember that this line makes sure that all the consumers found in the entry assembly, the assembly that starts the application, are added or registered with mass transit so that they can react when the message arrives. So that's pretty much what we have to do for consuming the catalog data into trading. In the next lesson, we will update the state machine so that it can calculate the purchase total by using the new pricing information that's coming from catalog. Let's now update our state machine so that it can calculate the purchase total based on the catalog prices that it is now consuming. Now, arguably, pricing calculation would belong to yet another microservice, fully specialized in pricing. But for the purposes of saving time, and since we want to focus more on the state machine capabilities, we will do a very simple calculation directly in the trading microservice. So what we can use in this case is what we call a custom state machine activity. So let's go ahead and add an activities directory right at the root of play.trading service, new folder, activities. And here let's add a brand new class. So new file, let's name it calculate purchase total activity.cs. Okay, so that's going to be namespace play.trading.service.activities. And now let's add our class name, which I'm going to just copy from the file name here. So I'll do Ctrl+C, copy in there, and it's going to be public class calculate purchase total activity. Let me collapse this. And then in mass transit, these state machine activities have to implement an interface that's called activity. So let's go ahead and implement activity, which is going to receive two type parameters. First one is going to be the purchase state, so the state, the class, the state machine class that we've been using so far, and also which is the event that provides information to the activity. In our case, that's going to be purchase requested, because we're going to invoke this activity just after receiving the purchase requested event. Now let's head back into activity. Let's do control dot, and we're going to do using automatomos. Next, let's click again in activity, control dot, and let's implement the interface. As you can see, we need to implement 4 methods here. And then let's go ahead into purchase state also over here, control dot, make sure we add the play.trading.service.state machines namespace. And also let's head over here to purchase requested, control dot, and let's add the play.trading.service.contracts namespace. Now what we're going to need is our catalog items repository so that we can read the prices, right? So let me go ahead and add a field here. It's going to be private, read only, iRepository of type catalog item, and it's going to be our repository. Let's do control dot using play.common, and let's also do control dot here for using play.trading.service.entities. Now let's go over here and let's do control dot so that we can generate the constructor with the repository getting injected into it, right? So I'll pick this option, generate constructor, calculate purchase total activity with iRepository of catalog item. So I'll click on that. And here's our constructor receiving the repository, and then it's assigning it right there. Okay, now the main method that we have to implement here is the execute method. So let's start with that one. And the first thing that we're going to do here is to try to retrieve the item, right? So, well, let's first capture the message object from context.data. So data has all the contents of the message that arrived into the state machine before invoking this activity. Now that we have that, we can say var item equals await. And of course, before we can do await, let's make sure we go back here and we say async task. And then we can do await repository that get async. And then we'll do message.item ID. And then if we can't find the item for any reason, if it's equals null, then, well, something is wrong here because we can't process or calculate the total for an item that does not exist in our database. So to handle that situation, we're going to just go ahead and throw a new unknown item exception that's going to receive message.item ID. Now, of course, we don't have this exception here, but it happens to be that this is an exception that we already defined in our inventory microservice. So let's go over there and grab that exception. So here I am in inventory, and I'm going to scroll down into the exceptions directory, and I'll just copy unknown item exception, copy. And then I'll just go into my Explorer here, Ctrl+Shift+E. I'll right click into play.trading service. I'll add a new folder called exceptions. And in that folder, I'm going to paste the class I've just copied. Okay, and here what we want to do, of course, is to change the namespace. Should not be inventory, this should be play.trading.service.exceptions. And the rest should be just fine. So I'll close this and I'll collapse that. And now we should be able to just click here, control dot, and we can import the play.trading.service.exceptions namespace. And so if we can find the item, then we are good to go in terms of doing the price calculation. So all we have to do is do this. So context, that instance, remember that instance is where we have the state of the state machine, or the current instance of the state machine. Then we'll do purchase total equals item.price times message.quantity. Okay, so remember that I said So this is something super simple. And of course, if you actually want to do pricing, you probably want to have another microservice just for that. But super simple calculation for the purposes of this course. Now let's also do context.instance that last updated is going to be datetime offset that UTC now. And then lastly, what you have to do is to invoke the next object so that mass transit can continue down the pipeline of processing any other activities in the sequence that has been defined. So in this case, we have to say await the next that execute. Then we just pass in the context. And then it's a good idea to also call configure await with false here. It's a good practice. Now we also have a few other methods that we have to implement here with really very basic implementations. There's not much to do here. In the case of accept over here, the only thing we have to do is just say visitor.visit.this just to comply with what the mass transit infrastructure is requiring. Then if we go down into our probe method, what we want to do is invoke context.createScope. And then this method is really to provide some information that we could potentially use to visualize the state of the activity if you wanted to. We're not going to do that in this course, but you still have to provide some implementation. So here what you want to do is some meaningful string representing what we're doing in this activity. So let's say calculate purchase total. And finally, we have to do some implementation for faulted here. So for faulted, we're just going to say return next dot faulted, and this is we're going to pass in the context. Okay, so we're just saying, hey, go ahead and move forward into the pipeline, and here's the context. And yeah, so that's what you have to do to define the activity. Now we want to plug this activity into our state machine. So I'll do Ctrl-Shift-E and go into our state machines directory, purchase a state machine. And what we're going to do is go down into our configure initial state method. And just before transitioning into accepted, which is when we already have captured the data about the request, we can say .activity. And then we pass a lambda expression here to configure the activity, which is going to be x.offType calculate purchase total activity. And then I'll do control dot right here using play.trading.service.activities. Okay, so what this does is that the message purchase requested arrives, then we capture all this information into the state machine, and then immediately we invoke the activity, calculate purchase total activity, so that it can do the total calculation, right? And immediately after that, we go ahead and invoke accepted. So just notice that this is just one way to do a more customized version of an activity as opposed to the ones that are built into mass transit. Now, there's one more important detail, that is the fact that, remember, if we go back to the activity, remember that we are throwing an exception in this case. When the item is null, we throw this unknown item exception. So we have to do something about this in the state machine. So what do we do if an exception is thrown? So to handle that situation, what we can do is open yet another section here with a catch. And we're going to say, well, if we catch really any exception, we're going to do something. So I'll just send ex here, and then we will say ex that then, and this then, let's send it to the next line. Then we are going to do yet another lambda expression here. Context, we are going to do some configuration for that then. Then we're going to capture the error information into the state machine instance. So remember, we have context.instance.error message. So here's where we can just place context.exception.message. Okay, so that object has information about the exception, and we will just put it into there so that we can later query it from the Postman, from the REST API. We will also say context.instance.last updated is going to be datetime offset UTC now. And of course, the state cannot just be accepted anymore. We have to switch to another state. And that state is going to be, let's open up another section here. We will say dot transition to faulted. So this is with parentheses there. Okay, so if something happens when we're trying to run the activity, an exception will be fired, we will catch it, and then we will receive the context and we will update it with the error message. And afterwards, we will transition into the faulted state. And then one more thing that we have to do about this exception is to inform mass transit that if this happens, there's no need to retry, right? Otherwise, mass transit is going to retry a few times as defined in our common library. So let's do something about that. I'll do Ctrl-Shift-E, and I'm going to go into startup, collapse this, and then we're going to go down into our add mass transit method, into our using play economy RabbitMQ method, and we're going to provide a retry configuration in this case. So we will say retry configurator lambda expression right there. I'll open up another line here, save. And we're going to say, well, it's actually the same retry configuration as before. So interval going to be 3 times, and then time span that from seconds 5. Okay, so let's do control dot and let's use green pipes. But also, if we capture, we receive an unknown item exception, let's not retry. So we will do retry configurator that ignore type of unknown item exception. I'll do control dot. Let's import play.trading.service.exceptions. Okay, and with that, we should be ready to go. The only thing that I'm going to do is just to put a breakpoint back in our calculate purchase total activity. Let's do it right here, just to see how the total is calculated. And then what I'll do is I'll make sure our identity microservice is up and running. So here I am in identity, and I'm just going to do .NET run. So that starts identity. And then before starting our trading microservice, one thing to realize here, and it's kind of a tricky situation, is that trading microservice has never had a chance to get updates from the catalog microservice in terms of the items and the prices. Therefore, it is really not able to calculate the purchase total. So before we can do that, let's go ahead and make some updates to our existing catalog items so that those prices and all those descriptions can flow into the trading microservice. And I think the easiest way to do that is by going into our current front-end portal. So first thing I'm going to do is just open up my catalog code base to make sure that it is actually running. So I'll do Ctrl-J, and I'll do cd-src, play that catalog service, and I'll do .NET run. And then I'm going to go into my front-end code base. This is the same front-end used in the previous modules, by the way. And so here I am, I have my terminal up and running. I just installed all the dependencies by doing npm install, so that's already done. Make sure you do that too. And then you can just do npm start, and that's going to start our Node.js server. And now I'm going to click on the localhost 3000 URL here, which should open the portal right there. Let's log in as the administrator, play.com. And now let's head into the catalog. And like I said, let's make a very simple update to, let's say, the prices of all these items so that trading can acquire all those prices. So I'll do edit. Price is going to be 6 for potion. Let's do, for the antidote, let's make it price 8. And for the high potion, let's make it price 10. And with that, trading should now have acquired all the prices, the updated prices. Okay, and with that done, we're actually ready to test the price calculation in trading. So I'm going to go back into our trading microservice. Right here, here's the code base. And I'm going to hit F5. And if we scroll a little bit down into this, the log of VS Code, keep going down, you're going to notice that indeed trading already consumed, right? Consumed the updated items, the ones that we just created in the portal. So that's great. So now let's go into Postman, and we're going to go ahead and do another purchase. So I'll head into our Post tab. We're going to go again with the same potion. Let's see what's the status of our tokens. Authorization, I'll say manage tokens. So it is still valid, so we can use the player 1 token. And I'll go ahead and say send. And now the breakpoint has hit in our new calculate purchase total activity. You can see that now price calculation is going to happen. It was able to find the item, the potion, and it got the price 6, the updated price is going to be multiplied by the quantity. So I'll just let it continue. And back in Postman, we got our updated correlation ID. So I'll copy this correlation ID. I'll go back into our tab where we can query the status of our state machine, and I'll replace the previous correlation ID with the new one, Ctrl V. And then I'll go ahead and hit send. And this is providing us the new state machine state. But notice that this time we do have a purchase total, which we didn't have before. So the calculate purchase total activity is working properly, and now we have a purchase total that we can later use to debit this yield from the user. And one more thing to try here is what happens if we try to purchase an unexisting item, right? So if we go back to post, and we'll go to body here, and instead of using this valid GUID, we use something that does not exist. So let's actually use the GUID function from Postman. So it's going to be a random GUID, something that does not exist in the database. Let's see what happens. So I'm going to go ahead and hit send. We got a correlation ID. I'm going to copy it. And let's query for the status in our get tab. Replace that with the new correlation ID. Hit send. And notice that this time the state is faulted, as expected. And not only that, we also get a reason of why the state for this state machine instance is faulted. So that's going to become pretty handy in the cases where we have some error happening across a state machine execution. In the next lesson, we will update the state machine so that it is able to grant items to the user. The main purpose of our purchase state machine is to grant items to a user and debit from him the required amount of yield, which it can only do by interacting with the inventory and identity microservices. Let's now address the first part of this equation by updating the state machine so that it can send the grant items command to inventory. And in order to do this, what we have to do first is to grab the NuGet package from inventory. So I'll do Ctrl J, and then I'll switch to src, play that trading that service, and then I'll just say .NET add package, play that inventory that contracts. Okay, remember this is what includes the messages that we can use to interact with inventory. Now let's go ahead and open our purchase state machine, and let me close terminal and collapse this. Let's go up. And in order to send the grant items command, what we want to do is go into our configure initial state method right here and open another section just after the calculate purchase total activity, where we're going to say .send, and this expects a lambda expression where we're going to receive the context. And from there, we can go ahead and create our message, grant items. Then let's do control dot here and do using play.inventory.contracts. And then let's pass in the required parameters, which are context.instance.user_ID. Then let me take this to the next line. Then it's context.instance.itemID, context.instance.quantity, and context.instance.correlation ID. Okay, so that's all that's required so that when the state machine starts, we go ahead and we capture, as you remember, we capture the initial data into a state machine instance. We go ahead and calculate the purchase total, and then immediately we will send the grant items command to the inventory microservice, after which we'll transition to the accepted state. Now, after the items have been granted, as you know, inventory will emit the inventory items granted event. So how can we consume that event back in the state machine to move forward to the next state? To do that, let's go up into our events section and let's add a new event. So this event is going to be public event inventory items granted, inventory items granted, again with a getter here. Then we configure the event as we have done with the other events. So it's event inventory items granted. And then what we want to do is to define a new section to state what do we want to do when this event arrives. So for that, let's go ahead and add a new method. I'm going to add it just right here before configure any. And let's call this one private void configure accepted. And here we're going to say that during the accepted state, because that's a state where we should be at this point, we're going to say when the inventory items granted event arrives, then we're going to receive this lambda, again with the context. Let's open and close there. Let's make sure we close semicolon there. Then, well, we can do something, right? In this case, the only thing we're going to do at this point is to capture the last updated time. So context that instance that last updated equals the time offset that UTC now. Okay, that's the one thing that we're going to do with the state machine instance. And immediately after that, we're going to say dot transition to items granted, which is our second state in the state machine. And let's make sure we also invoke this method from the constructor. So I'll go back over here into our constructor, and then I'll add configure accepted. Okay, so that's pretty much what we have to do from the side of the state machine. However, since this is a send operation, this one here, back into our configure initial state, since this is a send type of message, so we're sending a command into inventory, we also have to tell mass transit where exactly to send this message, because it is not just a publish event. This is a message that has to arrive to a specific location, a specific address. And to specify that address, we're going to be using what we call endpoint conventions in mass transit, which we can configure in startup. And to do that, the first thing we're going to do is to go into our app settings.json file, Ctrl-Shift-E, I'll go into app settings.json, and here, just after our RabbitMQ settings, I'm going to define another section we're going to call queue settings. And here we're going to define the address of the grant items queue. So we're going to say grant items queue address, and that's going to be queue inventory grant items. But then where is this address coming from, right? So this means that there should be a queue with the name inventory grant items in our message broker, in this case in RabbitMQ. But how did I come up with this address? Well, really this is due to the convention that we have established for all the queues in mass transit. And since we already defined an inventory grant items message in inventory, there should be a queue in RabbitMQ with this name. So to confirm this, let's go back into our inventory microservice right here. And I'm just going to go ahead and run it. So I'll go into src, play that inventory.service.net run. And now I'll head into RabbitMQ and I'll log in as guest. And here in the queues section, you can see that now we have an inventory grant items queue and an inventory subtract items queue, because we have defined the corresponding messages or contracts. So inventory grant items is a queue where we want to specifically send our commands so the inventory can perform the granting of items. So going back to trading, we have defined that queue. And now let's also define a settings class so that we can deserialize this data and then we can use it in the C# side. So I'll go ahead and create a new directory here under play.trading service. It's going to be settings. Let's create a new class here called queuesettings.cs. Let's declare the namespace. Play.trading.service.settings. Let's declare our class. Queue settings. And for now, the only thing that this is going to have is string grant items queue address. And this is an init type of property. Just remember that this name here should match exactly the name that you have over here in the app.settings.json. Grant items queue address. In fact, I'll just copy it to make sure and I'll replace it over here. Grant items queue address. And now that we have that, we can do the proper startup configuration. So let me go back into startup over here. And I'll collapse this. And in this add mass transit method that we have created, we're going to go down. Perhaps just before the add mass transit hosted service call, we're going to add one more call here, where first we're going to grab those queue settings, which actually I'm going to grab from this other line over there. I'm going to copy that line over here, and this is going to be queue settings, which is from the section queue settings. I'll do control dot. And then we will use play.trading.service.settings. And then we will deserialize as queue settings, right? We get it as queue settings. Now that we have the queue settings, we can set up our endpoint convention. To do that, we say endpoint convention dot map and then grant items. And then we say new URI queue settings that grant items queue address. Okay, I'll do control dot also here so that we can use play.inventory contracts, and that's all it is. So with that, we're saying that as soon as the trading microservice loads, it's going to know that it needs to map any command of type grant items to the grant items queue address right? Which, as we know, is the queue inventory grant items. That way, we don't have to specify this mapping every time we want to send a grant items message, keeping the state machine very simple with just this line. Okay, so now we can test this out. So we already started the inventory microservice. Let's make sure the identity is also up and running. So identity microservice, let's go ahead and I'm going to close these couple of things here. Let's go ahead and do .NET run in identity. And then let's head back into trading and I'll do F5. And now let's go into Postman. And before we perform the purchase operation, let's make sure we know how much of a specific item our user has so that later we can confirm that the item was actually granted. So to do that, we can query the inventory items REST API to get inventory back for a user. But before doing that, let's get the ID of our player one user. So I'll go into our play identity service collection, and then I'll go into our get users API. And we likely will need another authorization token here, an admin type of token, which we don't have right now. So I'll just scroll down. I'll click on Get New Access Token. This is going to be for admin. Login, proceed, and this is going to be admin. Use token, and then I'll hit send. So here we have the list of users, and here's the ID of our player 1 user, which I'm going to copy now. And then I'll collapse this, and I'll head into our play inventory service, Postman collection, into the get operation. And in the address bar, I'll say user ID equals the one that I just copied. And then in authorization, I'll pick our player 1 token because a player is able to query his own inventory. So player 1, and I'll hit send. So as you can see, the only thing that this user has right now is a 1 potion, nothing else. So if you head back into our first tab here, the one that lists all the catalog items, and if you don't have this, you can go ahead and query catalog items once again. But basically here we have 3 items. And so to make things interesting, we're going to use the antidote this time. So we're going to make the user purchase an antidote. So we'll go into our post tab now. And then let's go into the body, the post tab for the purchase, by the way. And then let's replace the item ID with the ID for the antidote. And then let's say that's going to be 5 antidotes, not just 1. Let's make sure we have an authorization token for this. It's going to be for player 1. And then I'm going to hit send. We got a new correlation ID. And so let's copy that to see what's the state of our purchase operations. Let's go into the get tab for the purchase status. I'll Control V, the correlation ID, and I'll hit send. So we have the total calculated properly. We have the right quantity, but there's something going on here. The state is still accepted when it should be items granted by this time, right? If the items were actually granted. So something is going on here. In the next lesson, we will understand why the state machine did not arrive to the items granted state and what to do about this unexpected scenario.